And we're live once again. Welcome to HaasTec 2020. We are on day number 3, I believe.
Day number 3. It's all coming. It's all already coming together.
I know. So today we're out in the products area again. If you watched us yesterday, this is building 2 of the Haas Automation Factory. Tomorrow we will be back
in the demo room. Well, I think we start here, and then we're going to go over to the demo room to look at Haas tooling.
I think we're doing both. So, like we've been doing all week, the same format. We're doing 2 live sessions every day. Today we start at 9 a.m. obviously.
That's right, and then we take a break in between to look at some pre-recorded video content that many of you haven't seen yet. That seems to be going over really well. We have a lot of people sticking around for that. And then we're going to come back at noon today.
Yep. So the pre-recorded content's got a bunch of cool stuff. We've got a full factory tour that Andrew did.
That's right. Brian did a tour of our sheet metal facility, which was also really cool. We've got some cutting demos, some maintenance videos, some other cool stuff in there.
Yep, a whole bunch of cool stuff.
So if you have time, check that out. And then,
but for sure, come back at noon Pacific, 3 Eastern for the second live session.
That's right. So today, in a minute, we'll get to it. We're going to look at a much anticipated machine, Haas's interpretation of a mill turn. Yep. And then Brian and Corey will be looking at an APL fit up to UMC 500.
Yep. We've got an auto parts loader with the UMC 500, and if you saw the auto parts loader presentation that Andrew and Milton did on Monday, this one will be a little different. So I encourage you to stick around and watch it. So before we get started, we want to mention the promo that we have running.
That's right, you got to mention the promo.
Yep, it's called Unlock the Savings, and if you go to HaasCNC.com, right on the homepage, you'll see it, you can't miss it. And this week, we've added a little kicker.
That's right, so you're going to get an additional 5% off the great deals that are already there. We have a really wide variety of machines that we're discounting. That discount lasts until Friday the 18th, 2 days from now. So if you're looking at getting a machine, or you're even thinking about it, as you always say, take the time to build and price it. You don't even have to talk to anyone. Just go to the build and price page, and you'll see the discounts there.
Build and price your machine, get a quote, or contact your Haas factory outlet, of course. Okay, I think it's time to get started here.
Yeah, let's get started with maybe one of the most anticipated machines we have here at the show.
I'm going to step out, Andrew.
See you a little bit later, Brian.
Yep.
So, the VMT 750. Now, thus far, in the show, pretty much everything we've been looking at is a production machine or a machine that's going into production pretty soon from now. I just want to emphasize that this is a fully concept machine. Yeah. This is Haas's first approach to a mill turn machine. But even saying that, this machine is fully functioning, as we're going to see in a second here.
Yeah, we hope.
I'm going to give a little bit of the credit to that to Bob Singh, another one of our product specialists here. And he's been working with this baby for the last couple of weeks. Yep. Fine-tune it. Yeah. Making sure there's no red lights. We'll see. So a machine like this, I mean, this is obviously it's sitting on a VF base here.
Yeah, it's based on a VF 3YT, and we've added an ST15 lathe spindle to the table. So it's on the left-hand side on the X-axis. So.
Right, and so this is,
there you go, you turn mill.
It's kind of a more interpretation of a mill turn than lathe focused.
Yeah, it's definitely based on the mill first, yeah.
But we're going to see that it still does, it can turn apart just fine, as we're going to see in a few minutes.
Yeah, we're going to do a demo. We're going to start with the lathe portion first, so let's talk about that first.
Yeah, let's do it.
All right, so we'll talk about the work envelope. Right now, if I orientate this tool to the turning position, from the tool tip to the front of the collet, the Haas lathe collet, which we'll talk about later as well.
At the end there.
Is about 23 inches. And then on the X-axis, sorry, there I go with the lathe guy again. On the Z-axis, which is your diameter, from the tip to the center of the part, is about 6.5 inches. So you can get a 12-inch, 13-inch diameter part safely in here with the right tooling.
When we were first looking at this machine, I don't know, probably 2 weeks ago, I was thinking that we'd be looking at a work envelope like that.
Yeah.
But really, it's pretty substantial.
It equates to the same as, it's more than an ST15 actually, but it will change. The work envelope will get shorter as the B-axis rotates, so that is another thing we have on the machine.
Right, we're going to see that the spindle head rotates 90 degrees.
Yes.
So yeah, you would eat up some space when you're fully rotated like that.
Yeah.
Okay, cool.
So just to explain the difference, I'm just going to go into
you want to talk about the spindle, I think?
So yeah, so we've got the HSK63A, and we've got the standard turn mill turning tools in that
so
spindle.
It's off-the-shelf tooling. This isn't some custom tool that we made.
Yeah, it's
for
just
this
off the shelf. Yeah.
Right.
So and what's going to happen is the tools get loaded in. If there's a turning tool, we'll use M19 to orientate to the turn position, and it'll lock into place with a brake, and then we can start turning. So
right. So it's held. That's how you hold it rigidly.
That's how it's going to get held.
Operations.
Yeah. And that's what we're going to see right now. So let's start with that.
Well, maybe real quick, you want to tell us, so let's say I have a Y-axis lathe.
Yeah.
What are the benefits of going with something like this?
Well, on the Y-axis lathe, you're restricted because your Y-axis and your X and your X minus as well.
You don't have that much travel on Y-axis.
So yeah, you end up, when you start milling, the only option is using C-axis, which is fine, but it's not the go-to way to really mill. You really want to use your X, Y, and Z, and this machine allows that to happen. Yeah.
Right. Okay. Cool.
Yeah.
Let's
fire it up.
Let's fire it up. What everyone's been waiting for. Okay, so we're starting with the turning, right?
We're going to start with the turning. So there it is. It just orientated. I don't know if anybody can see that. And we're going to come in.
Sal, you're going to push in a little bit here to see this.
The brake's coming on. It's just going to face the part, and then we'll start turning.
All right.
So although it is a concept machine, we are still using recommended speeds and feeds with this insert. So it is running at about 1200 RPM, depth of cut's 100th hour side. Feed rate's in inches per minute, it's 20 inches a minute.
So your metal removal rate's pretty standard, right?
It's 16 thou per rev. It's actually on the high end of that insert recommended, so.
Yeah, it looks like it's getting pretty good.
It's cutting solid, it's just like the lathe, so.
Yeah.
I'm excited because, you know, this is a concept machine and it works so well, so far.
Yeah. You've had a lot of successful runs of this thing, so we shouldn't see any surprises, I'm hoping.
Like I said,
maybe we have a get out of jail free card.
There you go.
Do, but maybe not.
So we're just roughing up a simple profile. I'm going to come in now with the finish tool.
Okay, so yeah, of course, oriented to take the tool out with a tool changer.
Yeah, locking it position. I'm just going to check the R value is correct. Just make sure it's engaging
Yeah, so you've
correctly.
got optional stops in here so you can.
Like I said about the X-axis and the Y-axis being larger, you can actually put a larger part in here that you can turn and mill here, whereas before maybe you had it on two machines. So
right. So it does, definitely gives you more options.
More options
in terms of travel this way, and a size part you can fit this way.
Yeah, and the final lathe tool we're going to use is the groove tool. We're just going to make a little groove at the back so we can start showing you the milling.
Right, and so it's probably obvious, but each time now you've got a different M19 orientation here for this tool, straight on to the part than you did for the turning insert.
Yes, yeah. But like I said, these are standard holders for all these lathe tool holders.
So what you would be typically, the alignment of your tool stick that you might typically be setting with between the tool holder and the turret is now accomplished all just by an M19, a different M19 setting, right?
Exactly, yeah. And let's talk about the lathe portion. It's just finished.
You bet.
So what makes me excited about having a lathe tool inside a mill spindle is I'm always worried about the neighbouring tools getting in the way.
On a regular lathe.
On a regular lathe in a turret, you're always worried about tools hitting the jaws or hitting the part or hitting the chuck.
Right.
This tool, I'm not worried about that.
It's all by itself in there, right? Yeah.
There's no turret and there's no neighbouring tools, so that's the exciting bit. Plus, on a lathe, you're restricted to how many tools you can put into a turret, and here we've got 50 tools.
Right, you might have commonly maybe a 12-station turret or something.
Exactly.
So this has got like 4 times at least that many.
Yeah, you got 50 tools in there, plus you don't have to worry about clearances, so there's no taking tools out of one position, swapping tools around, and you can build up such a big tool magazine of parts, so you can do all range of different parts without setting up, touching tools.
You've got a lot more jobs you can run potentially before you have to start doing
reducing setup time,
new tool offsets and stuff like that.
There you go. Yeah.
Cool.
So now we're going to do the milling. The first thing we're going to talk about is the B-axis. That's the different feature we've got on this VF3. So here we go with the mill portion.
All right. So of course you go and move away to a safe position and do the tool change.
Yeah.
So we're gonna watch it do the milling first, and then maybe we're gonna take a look at it. Just
if Sal can get in there, the first thing we're gonna do is actually go towards a part, and it will orientate to the B-axis of 5 degrees. It's just slight little portion.
So you're doing several different angular positions.
Yeah, the B-axis goes from 0 to 90 degrees, and what that allows is for us to do angled planes, so we can machine features on different angled planes. So today we're doing it on 5 degrees. Then we're going to move over to 15 degrees, and we'll show some. We'll show some 90 degrees as well,
right?
Correct. Yeah.
Yeah, so the 90-degree part is the part that scares me a lot.
Yeah, so we're just milling out a flat, and then we'll do a little pocket, and then it's just going to move out of the way. But as you can see, as it's traveling in X, the Z is moving as well, so it's keeping that 5-degree flat perfect.
Right, so you can't, it's a little bit difficult to see here on 5 degrees, but when you get to the 15-degree, particularly with the drill,
yeah,
you can see that those things are moving in you know, simultaneously, of course.
They're moving in sync, yeah.
Right. So kind of similar to how you do on a, very much similar to how you do on a Y-axis motion on our lathes.
It allows you to do more intricate and complex parts, so it does bring another dimension to this lathe, mill, and B-axis, yeah.
Right, right. So that was all okay, all the 5-degree there.
That was a
so
5-degree.
Now you're reorienting, or you're going to do a tool change?
We're going to do a tool change. We're going to do on the taper there, it's 15 degrees. We're going to mill a keyway.
Okay.
So that's going to orientate to 15 degrees.
So there you go.
And there you go. Yeah.
Now, obviously here, if you didn't have those axes moving simultaneously, up and down and in and out, you'd just be digging a big trench in your part.
Yeah, you'd be making a bit of a mess, really. So.
And probably, and certainly breaking the tool as well.
Yeah.
So these are Haas tools in here, by the way, right?
The end mills you're just seeing right now and the one before that, they are Haas tooling.
Okay, cool. Yeah, we'll take a quick look at those at the end.
Yep. So usually when you're doing complex stuff like this, it's done on several different machines, special fixtures. The cost can go up. I've just stopped the machine because we're not using any coolant. I'm just going to blow the chips off before we drill it. And then
right. So you're saying, yeah, this gives you the opportunity to do much more complex parts. That's what you're going to use a machine like this for.
Yeah.
You kind of have a story about how engineering here is. Probably most people know that engineering at Haas is always kind of trying to simplify things.
Yeah.
Which is always a good idea.
Okay, we're just going to quickly watch this.
Yeah,
Sal can get in and watch this. So we're at 5 degrees. We're just going to put a couple of holes into that pocket we just milled. But then we're going to swing around. It should play the part. Go across to B90.
Yay. There we go.
There you
go. That scares me every time.
And we're going to punch a couple of holes in the front face as well.
That is
so,
slick.
like I said, the options on this to make intricate parts is...
Right, so you could do a host of different kinds of machining on the front face of the part.
Yeah. And also the B-axis, you can machine on it, so you can do curve machining, you can do contour machining.
So we don't have tool center point control active on this machine
Not on this
yet,
machine right now, but it will be.
Certainly going to be planned for that, right?
And then the final tool's just going to come in and do chamfer the profile.
Right.
Yeah, like you said, with engineers, they've come down to the shop and they've said, hey Bob, we're going to design this, and I'm said, to keep the cost down, they've actually split that one component into 2 different designs so they can machine them easily.
Right, because you're going to have some milling and some turning, and so forth.
It can cycle time and cost goes up, so they reduce that by splitting up the parts.
But this machine kind of allows you to go the other direction, right?
It goes the other direction, yeah. I walked the shop a couple of weeks ago in assembly and found quite a few components that we could actually reduce into one just by having this one machine here.
That's slick. And there's a huge number of examples that out in industry. There's plenty of complex parts out there where you need this kind of machine for that kind of work.
Exactly. Yep.
Okay, so we did all of the chamfering there.
Yeah, so that's all finished. I'll show the B-axis just to show you about the
So you're going to just show us what you call vector jog, right?
Yeah. John mentioned it in the showcase yesterday for the GM2.
Right.
About if you are doing it at a vector, of doing it at an angle, and you're drilling and alarm goes off.
And something goes wrong.
Does something ever go wrong?
No, nothing ever goes wrong.
But your drill's stuck inside the part and you don't want to break anything. It's going to be really hard to come out at that axis.
Yeah, because if you couldn't jog those, if you can't jog the axes together, then you're gonna break something.
Something's going to break. So I'll tell you what we'll do. We'll just come down here, move the B-axis to a certain angle. Let's go 25 degrees. Okay, so right now, if that's stuck in a part, you're not going to get it out by using X, Y, or Z.
Right.
So, but you can,
like you were saying, you're probably going to take the part out if you can.
Yeah.
And pull it off with the drill.
Yeah. But a vector jog it's easy to. It highlights the whole.
Yeah. So that's cool. So that there you're in that mode.
Yeah. So now, as you can see, as I'm going up in Z, the X table is moving across as well.
Right.
So that drill
you can really see the you can see the simultaneous motion there easily. Now all you've got to do is remember which way to go, right?
That's true. Yeah.
Not being a machinist, that's my problem.
Yeah. And that's it. That's the mill turn.
Well, let's we want to take a quick look at some of the tools that we're using here, right?
Yes.
This is all stuff that's on HaasTooling.com.
Yes. If Frank can pull up.
Yeah, Frank,
the
you
first
want to
slide?
pull up those slides?
Yeah.
Cool.
So the second section, the mill section, we were using 2 end mills and a drill. That's from HaasTooling.com.
Right. So we got those here, end mill, and then this is one of the inserts you're using.
Now
well,
the lathe
right?
inserts are soon to be released.
Yeah, the lathe inserts aren't on HaasTooling.com yet, but they're soon to be there, along with a host of other stuff that you're going to see tomorrow over in the demo room. But we also want to look at another thing that is coming soon.
Yeah, it's the Haas collet chuck, and this is it here. We were talking before about reducing setup times. Like I said, with 50 tools in the pocket, you can set up a whole range of parts and save those tools and never have to remove them.
Right, and the other half of that is something like this.
This option is fantastic. So what I'm going to do right now is I'm going to say we finish this setup.
Essentially swap out a job, right?
Yeah, we'll take this part out.
I'll give you that.
Here's one I prepared earlier. Right, so I'm going to
that's right. I can't give you that first.
Yeah.
What am I doing?
Going to use a collet gun. I'm going to remove
so
that.
You pull one collet out.
Yep.
Just go blow it out. Yeah.
Make sure everything's clean.
So that index is in there. You've got some kind of alignment tab or something, right?
Yeah, that's it.
All right, that was pretty quick.
So far, so good.
This is the easy part.
So now we've got a 1-inch bar. Stick out what size you want. You're actually ready for the next setup.
You're completely switched over, and your work offset is probably going to be off of the face of this truck.
Exactly.
Right?
So
that
you can
hasn't
continue
even
running.
changed.
Yeah, you've
as long
set
as
up
your
for the next
program
job.
references that.
Correct.
So you've got a huge number of tools up here for a huge number of jobs, and you've got really quick swap or switch out there.
So the gun and the collet chuck plus the master jaws, they're all going to be available soon on HaasTooling.com.
So super high production possibilities here.
Yeah.
So that kind of wraps it up for the VMT 750, right?
Yep.
Thank you so much for showing us around and getting this demo running, because I know people are pumped to see it. I certainly was. So as we were mentioning, this is definitely a concept machine, and given that, we're really interested in knowing what you think of it and what ways would you use this machine. A little birdie told me that we're thinking about a price range in the $150,000 range. So take that into consideration. Of course, there's a lot of complexity here. What kind of parts would you make with a machine like this? What kind of applications do you see it being used in? And would you do things, do you have any suggestions? We'd love it if you'd add something in the comments or in the chat to let us know what you think of this, and we'll be watching those carefully. Given that, I think we're ready to switch over to the next machine here. Coming up, we have Brian and Corey on the UMC 500 over here, and they are going to look at how we've attached the automatic parts loader to that machine. Brian, you ready?
Yeah, sorry,
all right.
I was watching your presentation on my phone.
Stop that.
No lie. All right, so thanks for that, Andrew and Bob. That was super cool. Okay, so I'm with Corey Sullivan. If you were with us Monday morning, Corey and I talked about robots. So Corey's kind of our automation expert. Today, we're in front of a UMC 500, as you can see, and this time we've got an APL or auto parts loader paired with the machine. So the APL is what we call affordable automation. And the great thing about it is how simple it is to integrate and to set up. As a matter of fact, several months ago, we did a video where we grabbed one of our accountants, Luke Huco, and brought him down and asked him to run through the control and see if he could set the machine up. And I have to tell you, in all honesty, he did about 90% of it without any help. And so what Corey's going to show us today is how he sets it up. We're going to run through the VPS templates, and Corey, I'm going to let you take it away.
All right, yeah. So like Brian just said, it's very simple to set up. We showed it off on the mill and the lathe on Monday, I believe.
Monday afternoon.
This is essentially the same thing. And very similar to the robot as well if you watch that. But for anyone who didn't see that, we'll go through everything again. So basically, when you have your APL installed, well, first I guess I should show you that APL itself. We got a light curtain here, comes with it.
So
you got the table and the APL arm itself. And that is basically, on the UMC we have a door on the side here as well. This is not normally on a UMC 500, but obviously you need a way to get your part inside the machine.
So we've got 2 grippers on the APL arm.
Yep. And just like before, you can actually set up the grippers for, one is for the raw, one is for the finished. And this part, we actually have the fingers in different positions here. So if you machine a lot of material off your part, you can grab a much bigger raw than the finished part if you need to.
So you reset your grippers according to the size of the part.
Exactly.
Okay.
So then to set up, you'll come over to the current commands page and you will see, instead of just the normal mechanisms tab, you'll also have a automatic parts loader tab with 4 tabs underneath that. So you'll have a template tab, a load part tab, an unload part tab, and a run job tab. And they all do exactly what that sounds like. So
and
template.
So the idea, sorry to interrupt, but the idea here is you've got 4 tabs and you want to go from one tab to the other and simply go top to bottom and answer the questions.
Exactly. You go left to right on the tabs, and in each tab you'll go top to bottom and just go in order, and it makes it pretty easy. There's even we go down here, some GIFs or pictures, which will show you exactly what it's asking for. So here we go. We'll go through and we'll see.
Yeah, let's start from the top.
So we'll start from the top. First one is slug, puck, or a bar stock. And basically, slug or puck, you'll grab just a normal part. The bar stock is more for longer parts. So you'll see on the picture there, it shows you if you have a long piece of material there, you can grab with both grippers at the same time.
Okay, that's pretty simple. It's a 0 or a 1.
Yep. And then you'll have your part pickup method. And that is basically you can have a conveyor feed coming in to feed into that single pickup position instead of the normal table grid we have set up right now.
So if you were to not use the table but have a conveyor and pick it up in the same location every single time, that's what you would use.
Exactly.
Okay, makes sense.
And then you got the same for the drop-off method, if you would rather drop off at the table or a single point.
Okay, simple enough.
Okay, then it's just going to ask you, you can see on the camera there, we just have it set up in a simple grid pattern there. And it asks you for the number of rows you have, the number of columns you have, the distance between the rows, and the distance between the columns. So you can have different distances between rows and different distances between columns, but if you make your own template, which most people will be doing, especially on a mill, you'll want to make your own template most likely.
Right.
And you will evenly space each row and evenly space each column. So you can't space each row differently, but you can space the rows differently from the columns. So if you have a long piece again, it's 6 inches long, you don't want your next row to be 6 inches above that part. You'll just waste a bunch of space on your table. So you can differently space them.
And template-wise, what does the machine come with as far as templates?
The mill, I believe, comes with no templates actually, because
just want to make that clear.
We could include one, but
we have no idea what shape your part's going to be. It would be impossible. So on the lathe, we do include some because we're pretty sure your parts are going to be round. But on a mill, we have no clue what the part size is going to be or the shape. So, okay. So we've gone through and we've set the rows and the columns and the distances.
Yep.
Okay.
And then the next tab will be the load part tab, and this is where you'll actually program how you're going to load your part into the machine. And this one I can show you a couple things on. So first you'll ask you for the clamp type, OD or ID. You can clamp on the outside diameter or the inside. Or then you got the clamp delay, and that is just the time after the grippers have clamped before the arm will move. And we recommend just leaving that at the default 2 seconds. It's seems to work good there.
Just to make sure. Yep.
All right, then the initial pickup location. And
Frank, hopefully if you have it on VNC Viewer so
Okay.
you can see the animation, the GIFs on the screen.
yeah.
Okay.
So you see it asks for 3 different axes there. You have AU, AV, and AW. And those are the APL arm axes. And just like X, Y, Z, W, U, and V are your machine axes. So, or UVW, I should have said. X, Y, Z, UVW. So, you know, U would be essentially the arm's X, V would be the table Y, and then W is the Z of the arm. It's an easy way to think of it. So it's asking for those 3 locations. So if you press handle, go into handle jog mode, and then let's go back over to that display page here. We'll pick this first part up and set it. So you see, I'm just going to use the touch remote jog handle we have on here. You can see on here again that we have an AU, an AV, and an AW axes, and then the speeds at which, if you want to come and maybe get this on the
Maybe
camera.
tilt that down a little so the lights don't.
Oh yeah.
Tilt it forward a little bit. There we go.
Can you see that all right?
Okay.
All right. So, and then the speeds at which you can jog it, just like on the Haas control normally. And then you can hit grippers down here, and you can clamp your grippers from the remote jog handle as well. So I'm just going to use this to jog the arm over that first part, you know, and show you how to record it. It's pretty easy. So first I'm going to move it over in AU.
Select your speed, then select your axis.
Yeah, exactly. Select your axis. You just touch it on the touch remote jog handle here.
Okay.
So you can see now the arm's moving. And I'll go down in AW, get it a little closer to make it easier to see where I'm going. Okay. Let's move the table. And just like the GIF shows too, the GIF will show you exactly what it's asking for. You get the arm back. If you're not over it already, I was already over it, so I didn't do it. Insert will move it to the location that it wants, pretty much. Then it shows you there to jog it over in AU, line it up in AW, then come back and fine tune it. So I'm gonna do exactly that over here. So I'll come over here just so I can see it better. It looks roughly in the center of the part there. Get the table. Okay, go down in AU, or AW, sorry. There we go. And right about there, looks pretty close. So then I'll hit gripper just to see if it moves too much. Didn't move too much, so it looks pretty good. And then I can press F2 to record that position on the screen. So now you'll see, instead of just being all zeros, it's recorded exactly where the arm is. So every time it wants to pick up your part, it will go down to exactly that location.
So just to be clear, the front right is always your position 1.
Yeah, so if some people might have noticed, actually the GIF is incorrect. We've actually already fixed that. It's just, we haven't uploaded the new GIF into the software yet. So it's already in there. By the time you have it, it'll be fixed. So.
Okay, so jog it over by eyeball, using the remote jog handle, come down over it. Once you're good, F2 and your position's recorded.
Exactly.
Okay, and the control already knows where all the other parts are located based on your setup earlier.
Exactly.
And your spacing between rows and columns.
Based on what you put into the template tab. So basically it'll just add over. This one's actually 4.4375, so I think, what is that, 5/16? Something like that. 7/16, sorry. And then, so it'll move over by that amount each time. So it'll pick up each one along that row first. So, you know, it'll add that 7/16 and then again and again, and until it gets to the end of ever many columns you've inputted, and then it'll go over to the next row, and then it'll go over by that amount in the row.
Down the rows, and then it moves up one column to another.
Yeah, and then it'll go down each column again until it's finished that row, and so on.
Got it. Okay, so that's our pickup position. By the way, I noticed on the control you triggered the light curtain. We should probably talk about that real quick. So during setup mode, it doesn't matter.
Yeah, during setup mode, it doesn't matter too much. But when it's operating, when the arm is operating, if you see it comes up here, it says light curtain triggered. When it's operating, it'll stop the APL motions, all the APL motions completely. But if you were machining a part and the arm was moving to pick up a part, you can interrupt the light curtain and the machine will keep machining. That's separate. So the machine will keep machining. The arm and all the APL motions will stop
so it's
because
essentially it's a feed hold on the APL only.
Exactly, yeah.
The machine. Okay.
So you won't interrupt your machining by interrupting the APL light curtain.
Got it. So if you're machining a part and you want to do some setup over here, you're good to go.
Yeah.
Okay. All right. Sorry to interrupt. I just saw the notice on the control. Wanted to cover that. Okay.
Yeah.
So we've got our pickup position. What's the next position here?
So then the next one we have is ready location.
Okay.
And just like the GIF will show here, it says go up in AW just to get it off the table a little. So I'll do exactly that.
So same thing, you're gonna go in, handle jog.
So I'll come up here a little. And then so I don't have to jog it all the way myself, it says press insert to move to ready, the ready that is pre-programmed into the APL, which is the safe position. So we'll press insert, the arm will come up. And that's the pre-programmed ready position right there. But since you're recording this position, you don't have to keep it at this spot. You can, so that you're not waiting over here, and then when the door opens, you're not waiting for the arm to go over in. I can actually bring this, let's go.
So we've got it over there in case you have a big part. It's just right in the center of the table, nice and safe no matter what.
Yeah, and that's just a little helpful button there, the insert to speed up that.
So you're not jogging for
yeah, you're not
3 minutes.
Exactly. So I would probably leave it around here if I wanted, and I could record this as my ready position.
Okay, so same routine, you jog it in position, hit F2, and that position's recorded.
Yeah.
Okay.
And so that will, now when you're machining a part and it wants to wait to load the next part in, it'll wait over here instead of that pre-programmed one.
Okay.
All right. Then the safe axes location for load is next, and this will record, again, just like it says here, has a GIF to show you. Again, it says jog internal axes to ensure clearance for loading and unloading. And then you'll see it has a T0, X0, Y0, Z0, B0, and C0. So there's a couple more axes on the UMC than the mill, the standard mill.
So what this is doing, and Sal, you can come in here, I think, it's putting all the, let's say you had your B and your C axis rotated at the end of the program for some reason.
Yeah.
Before you load your next part, you definitely want your B axis at 0 and your C axis oriented so the jaws are in the correct position.
Yeah, and you can see actually right now that the jaws are at 45 degrees to the part. So I would actually jog that. Let's see if I can do that right now. So I would jog the C axis to get that square to the part, basically. So now when it loads it in, it can load it in and grab the part correctly.
Okay. Now there's also a tool in there.
There's also a tool in there.
Which you may not want.
Yeah, and if it was a big tool, this one wouldn't actually get in the way of us loading if we put that as our position. But something to note on the UMC as well is if I hit home here, I have to put the remote jog handle down first, and then, so home position is here on the UMC. So you'll, obviously that's in front of the arm over there.
Yeah, you don't want it there.
Yeah, you really want to set this location in a safe spot. So basically 99% of the time, you'll probably just jog this all the way over in X.
As far away as you can. No reason not to.
Yeah, and then in Y, well, first actually I should have done the tool change because that's going to move the position of it a little bit. So let's do that. I know tool 7 is empty. So again, gotta put this down. So we'll put on an empty tool there, so now there'll be no interference between the arm and the tool. Go back into handle jog mode and over to this tab. And
so
now,
sorry, I got you out of order. Now you got to get the C-axis back in.
That's all good.
In location.
So push Y all the way back, X all the way out of the way. I'll turn my C-axis again, so it's square to the part. And then I would press F2 to record that position.
So now every time the APL arm comes in to load a part, it's going to change to that tool.
Yep.
It's going to move X, Y, and Z to those locations,
Yep.
and it's going to square up the C axis.
Yeah. Yeah, it'll move to whatever you have it recorded at. So you'll see it says B -0, C 45, because the jaws are mounted 45 degrees to the home position.
Okay.
Okay. And since I've already showed you guys how to move and record the arm, we'll not actually record all the positions because I have a pre-recorded program for that.
Okay.
But I'll explain them anyway, because the next one would be chuck location. Basically, you'll open the door, put this the safe axes for load, leave them where you have it recorded, and then you'll come in and record that. And now, if a cool thing is if you have, so say you had your C roughly there, but you couldn't see if it was perfectly square to the part, you weren't mounted perfectly 45 like this or whatever, you could come in now with the arm, set the part where you want it roughly, and then fine tune it, and you can...
So you could set the part in the vise and then check your vise and make sure you're dead on.
Yeah.
Okay.
And then you could record that chuck load location, and that will actually record over those last couple machine axes as well.
Okay.
All right, so then you got alignment, and that one's very simple. You just come straight up and record that position.
You just want
Just
to come
above
up,
the-
clear your work holding.
Exactly, once it's let go of the part, you want the fingers to clear the work holding,
Yep.
and then that's just gonna be where the arm comes out at.
Okay.
So unload part should look very familiar. It's basically the same things it asked you on the previous tab, except for unloading now. So same thing, you got grip or clamp type, OD or ID, clamp delay, just like we said, probably leave that at 2. Internal axes for unload, which is the same one we just went over. So it's very simple. Vise pickup location. This is instead of dropping off, where you're gonna pick up from, because you're picking up a part that's been machined now, could be lower, you know, material's been removed, and your fingers could be in different positions, and you're gonna be picking up with the finished gripper this time.
But same routine, you jog it in, you get it over,
Yep,
clamp it, press F2, and that position's recorded.
exactly. And then you got alignment, same thing, just come straight up so your fingers and part will clear.
Okay.
Drop off location will be, again, where you're dropping the finished part off at now, so you're not dropping it from the exact same location as the initial pickup location, because it could be a lot smaller part now. You don't want to just dump it onto the table. Or
Right.
So, and then air dwell, so you can blow the jaws off after, after it's picked up the finished part, before it loads in the new raw.
So the arm will get out of the machine, the side door will close, the air blast will be triggered,
Yep.
clear the chips off your vise jaws, and then it'll load the next part. So
Exactly.
if you're running fully automated, you would probably want to do that just to make
Yeah.
sure.
Yeah.
I guess we should probably mention, Sal, sorry to have you come back over here. I had a couple questions about this this vise.
Oh yeah.
So, because that's something unusual. So this is a hydraulically actuated vise?
Yep. Yeah, it's a hydraulic vise. We're going to be selling. I'm not sure when.
Well, yeah, this is kind of a coming soon. This is another kind of engineering R&D project. We'll be talking more about this in the future, but we did have a couple people asking what the heck is the vise on the table. So I just wanted to cover that real quick.
Yeah, it's just a hydraulic vise. It works pretty nice. We'll be using it for the cutting demo, which we'll run in a second here.
Okay.
And so you guys will get to see it in action.
Actuated with a foot pedal, just like
Yep.
a chuck on a lathe.
Yep, you can actuate
Okay.
from the foot pedal or from the control.
Okay, thanks, Sal. Okay,
You can
I keep
actually
interrupting you.
Oh yeah, it's fine. So then you see on the load part, unload part, it has F4 also, because we have work holding 1 custom vise, which is the vise we have installed right now. So
Okay,
you can also actuate the vise from the APL tab as well.
okay. Okay, so you've obviously got a demonstration ready to go, and this is
Yeah.
where you run your job from.
Yeah, so then the last tab is the run job tab, and this will show, it's hard to see now because there's no program loaded, so I'll go over quickly and show you when I've loaded mine. So We got current part 0, next 1, completed part 0, total parts 1. And that does exactly what they say. It's which part it's machining, which part's the next part, and then how many total parts you want to run.
Right.
The rapid override, that is the rapid override for the APL arm. So if you don't want to run the APL arm at 100% rapid, you can run the APL arm slower. And then you have a slow rapid distance, and this one's pretty cool. I used it in the demo program as well. So basically you give it a distance before it goes to the slow rapid override. So I believe in my program I used 5 inches. And then I used a 20% slow rapid override. So what that means is when you get 5 inches above the final location of that movement, it'll slow the arm down to 20%. So I like to do that when it's coming in to pick up the part or place it in the chuck, just so it's not happening so fast you can see it if it's gonna crash or anything. So, and then you got the arm state. At the bottom here we have new job, save job, and load job. Basically new job, if you press F2, that'll ask you if you want to clear it. I should leave that on there a little longer. And it says yes or no. That'll just clear everything out so you can start from scratch. And then you have save job, which I'll press the button right now, but we're not going to save this one because I just cleared everything. There's nothing in there to save. And you'll just save it probably in the user data my APL folder somewhere. You can see my other ones there. And then we have load job tab, and so that I will load the demo program I had prepared for today called HaasTec 2020. And so you see now it's changed all these fields, and if I go to the other tabs, it's changed all the fields and filled in the values that I recorded earlier. So now everything's as it should be for the demo. We just got to put the arm back. So I will take the part that we're going to machine out of here so we can start the APL sequence from the beginning.
Yeah, I guess you need your first part of the table to run the demo.
And so then you have insert APL mode on the run job tab as well, and that is useful because this program here, what's really cool about the APL is you don't have to change or modify your part programs in any way. It runs just like a regular part program, except for at the very end, there's an M299, and it'd normally be an M30 or something like that. M299 outside of APL mode will work just like an M30. It'll reset your program from the start and end it. So if I ran the program like this, it would run without the APL at all, and it would just machine your part like normal. But if you come over here to the current commands page again, automatic part loader tab, run job tab, you'll see insert APL mode on. So I hit insert, and now is the VNC viewer up, Frank? Oh yeah. Okay, you'll see APL mode on displayed over my program here, which I'll reset back to the top. And that will put you in APL mode. And now, when it hits that M299, it'll know that the part program is over, and it'll start the APL sequence. Also, it'll start the APL sequence before you've loaded a part in, obviously, so you can get that first part. So, I think we're ready to go. Hit start. See the arm move over here. Now it's going to pick up my part from the initial pickup location I recorded and go to the ready position. And now the machine is clocking its internal axes. We can maybe get that on the second part. So now, once the arm's gone to that initial pickup location, it'll clamp the vise, unclamp the APL grippers, and then get the arm out of there and close the door. And now it'll start the part program. This is so if you notice too right there, as the part program is running, the APL arm actually came over and grabbed the next raw and got into the ready position, and I just triggered the light curtain there, but as you see, it didn't stop the machine from machining. And now it'll wait here with the new raw so it can swap it out. once this part is done machining. It's a pretty simple 2-part program, or 2D part program. It's very just something quick so we can show you how the APL runs. I think if there's
so Corey,
any
yeah, while this is
questions.
running, you can stay there, Sal. We had there's a couple of questions. Does the machine require the auto door and the remote jog handle?
So the UMCs don't have an auto door for the front, like the normal the VF series.
Yep.
Instead, we have it. The APL needs to get the side door installed.
And that when you order the machine with the
for the
APL, you
UMC.
get that.
Yeah.
Remote jog handle is standard
Yes.
because it's required, as you can see
Yeah.
from Corey walking all the way back and dialing the parts in. You got to have that.
Yeah, you have to have the remote jog handle.
Another question: what's the maximum capacity of the
maximum
APL
capacity.
in terms of part size and weight?
Part size and weight is the grippers can grab a 6-inch part, and the weight is 15 pounds per gripper, I believe.
Okay.
It can do longer ones, since you saw earlier on the template tab, you can 6-inch wide, but you can actually grab a longer part because you can use both grippers to grab that stock.
But then, of course, you don't have to use the grippers that we supply. You can make custom
Yeah.
grippers, which I'm sure
Yeah.
a lot of people will be doing.
Yeah, you can make your own custom grippers or order them and mount them to the arm.
Okay. So you've designed this demo. We're not going to be live and run every part on the table. I
Yeah.
think we'd be dropping viewers like crazy if we did that. So we're just going to do, this part's got what, one more tool left?
Yeah, so it's pretty short. It's just going to tap the holes here, and then once the holes are tapped, it'll flip over, blow the chips off, dump the coolant, and then the APL will come and unload the part.
Okay.
We're almost done there. So you see, this is not the APL actually air blast sequence. This is
So
just
we're
something I programmed.
Dumping the coolant out?
Yeah. So that's one of the benefits of the UMC as well. So you had a part with a deep pocket or something that gets filled with chips and coolant. You can dump all that out before you
Nice.
unload it. So
Now we're in the,
now you'll see it's going to do the internal axes for unload. So it goes to the tool 7 I told it to, which is just a blank spot, go all the way away in X, all the way away in Y. And now it will open the door. It's open. Oh, it's because I triggered the light curtain, so it says light curtain hold. You have to press cycle start again after that.
okay.
So I could have pressed cycle start also while it was machining, and that would have started it automatically as well. I just didn't press it, I forgot to. If you don't interrupt the light curtain, you don't have to press cycle start at all after that. It should run automatically. So now it comes out, closes the door, blowing the jaws
That's
off
your
there.
air blast inside.
That's the air blast sequence for the APL.
Now we're
And
gonna
then it'll load in the next
raw
part.
material.
All right, so that's about it. Well, actually it has to drop off, so it's gonna drop off the finished part there.
Cool. Okay, I think we can stop it.
Yeah, I can stop.
Okay.
So if I hit feed hold, it feed holds the machine and
Machine
the
and the
APL.
Okay.
And then I'll just hit reset, stop
I
it.
think that wraps it up. Corey, thanks for showing us the UMC 500 APL. We are going to be back at noon Pacific, 3 Eastern. We're going to be going just right across the aisle there. Andrew and Marcus Imes, who's answering chat questions right now, are going to talk about a UMC 500 SS, but this one is going to be paired with a pallet pool. So between now and then, we've got a bunch of pre-recorded content, as Andrew and I mentioned at the beginning. We've got some cutting demos, we've got a factory tour, we have a tour of the sheet metal facility, a whole bunch of stuff. So encourage you to stay online the whole time, and we'll see you back live at noon Pacific. Thanks for watching.
Introducing My Haas, a free feature available to anyone on HaasCNC.com. If you are a current Haas owner or machine operator, if you're involved in buying or maintaining Haas machines, and even if you are not currently a Haas user, but want to build and price a machine online, My Haas has something for you. Monitor machines in your shop with My Machines. Here, you can see all the machines you're responsible for and group them in whatever way you'd like. Operators and supervisors can even create their own groups in a way that makes sense to them. Click on any machine and quickly see your machine's serial number and warranty start and end dates. Scroll down for a complete list of that machine's options, including recent service updates, or with a single click, jump to the product detail page to check specs, layout drawings, even to download 3D models. In the event you need to order a part to service your machine, or if you're looking for a performance-enhancing option, Haas Parts is just a click away. As if that's not enough, our helpful and thorough service website is also right at your fingertips. Here, you'll find comprehensive troubleshooting guides, how-to procedures, videos, and operators manuals for just about every vintage of Haas machine that we've ever built. And the best part is, all of this helpful information and all of these support services are pre-filtered based on the machine you've already selected. The My Haas Connect tab lets you see the status of every Haas NGC machine in your shop at a glance. Scroll through for the current status and last recorded event for each of your machines. In My Quotes, build and price as many machines as you'd like and save them for viewing or editing later. This makes it easy to compare machines and find the one that's right for you. From there, you can send the build and price to a coworker or friend or anyone who might be involved in the buying decision. And when you're ready, send it to your local Haas factory outlet when it's time to move forward. My Haas allows you to be more efficient and manage your shop and your machines like never before. And best of all, it's completely free. Create a free My Haas account today.
You know, it doesn't take much effort to install the Haas robot package on your mill. You literally roll the robot right out of the shipping crate. All you need is a tape measure and a simple bubble level to align it. The cables that link it to your control are all clearly marked and ready to plug in. Your service tech will drill a couple of holes and move some shelving to get the enclosure ready to accommodate this huge leap forward in automation. And that's the mechanical part. But what about integration? Well, the Haas control's already set up for the robot, so your service tech will have the integration done in well under an hour. And that's it. It only takes about a day to get your versatile, efficient robot package installed and ready to start making you money. If you're ready to take a step into automating your production, the affordable, versatile, and easy to install Haas robot package could easily be what you're looking for.
Welcome to Factory Spotlight. We're in front of Haas Automation in Oxnard, California today, and today we're going to give you a tour of the demo room. I'm Brian, he's Andrew, and Andrew, let's head through these doors and take a look.
All right, let's head through the front doors here, and we're gonna head off to the right towards the demo room. As you can see, we got several trophy cases from all the different various race car wins we've got. Driver's suits, helmets, memorabilia, of course. But here we go into the demo room. You can see the sign there, and you're gonna start us off, right, Brian?
I'm gonna get rolling. The first thing as you walk through the doors, you can't help but notice a car. So why do we have a race car in the demo room? Well, this is the car driven by Kurt Busch in March of 2014, and it was his first win as a member of Stewart Haas Racing. And as you can probably see, this car is in the exact same condition as it was when it came out of Victory Lane. It's covered in, I don't know, beer, champagne, Gatorade, you name it. Pretty cool accomplishment, and we haven't even touched it. We literally rolled it right in here. Right behind me, this is kind of the star of the show. This is the very first machine ever built by Haas Automation. If you've ever seen our mill names, VF1, VF2, VF3, etc., this is the VF1. And that name comes from, remember, we had no marketing department back in the day. VF1 stands for very first one. Back in 1988, the goal was to build and sell a machine for under $50,000. And that's exactly what Gene and his team accomplished. This went to IMTS in 1988. We had a couple of folding tables and one machine. We sold a whole bunch of machines. It still runs. I'm not going to turn it on today, but the thing still operates. You can also see, really before even the first machine, the way Haas Automation started is Gene started making rotary indexers. Put a stepper motor on an indexer, and instead of indexing that thing manually, now you had a powered indexer. Also in here, we sold our 200,000th machine a few years ago, and the customer was so appreciative. They have many Haas machines. It was a UMC 750 that they made this and actually presented it to Gene at IMTS. So pretty cool piece of memorabilia here.
All right, so we're gonna go from one of our oldest machines to perhaps one of our newest offerings. As you can see, this is our small footprint ST10 turning center that's married up to what we call the Haas robot package. And this is the smallest robot that we're offering right now. This got a 7 kilogram payload, 6-axis robot, and what's really kind of amazing about this assembly is that for the same price that we were asking for that VF1 initially at $50K, you get this entire robot package for $50,000. That gives you this safety enclosure on the outside. The robot, of course, itself, it comes standard with a single gripper. There's also an option for a dual gripper. The base, all the mounting hardware, the robot controller. But what's really kind of the most important and the most useful for an operator or an owner is that this thing is plug and play, ready to go. There's no robot integrator needed or anything like that. And the beauty of it is when it comes time to programming the robot, all of that is handled through the Haas control. We use a series of menus in our familiar VPS system, and through those menus, you control the programming of the robot, and you also jog the robot with our remote jog handle, which has been updated to control the robot. So just a fantastic package and a really easy entry into the world of automation. Moving on, let's go over here to this VF2 SSYT. The VF2, of course, is one of our best sellers, our small footprint VMC. But this is the Super Speed Y variation. Super Speed, of course, gives you faster rapids and cutting speeds, 1400 inch per minute rapids, 12K spindle, 30 pocket Super Speed tool changer, and then in this case, the Y option gives you additional Y-axis travel for a deeper work envelope this way. All right, that pretty much wraps it up here for the VF2 SSYT. Let's throw it over to Brian.
All right, as Andrew said, right next to the VF2 SSYT, we've got the DT1. Now, DT stands for drill tap. This is a super fast little machine, 2400 inch per minute rapids, tool change in under a second, but it's got great milling capability too. It's got a 15 horsepower spindle. Speaking of spindles, 10,000 RPM is standard. You've got 12, 15, and 20K optional. So if you're drilling a lot of small holes and you want that high RPM, you can get it with this machine. Now on the table here, we've got a real fast 2-axis rotary. This is what we call our TRT 100. So DT1 with the TRT 100, you have full simultaneous 5-axis or just 3+2 capability. Now we're gonna move from the DT1 just to the right here to the UMC 500 SS. So this happens to be an SS, a super speed, but we have the non-SS as well. This is the smallest of the UMC family. So this is the UMC 500. We also have the UMC 750, and then the big boy is the UMC 1000. Now the nice thing, the great thing about the UMC 500 is its size. It's a compact footprint, similar in size to a VF2. So if you have a small shop, but you're wanting 5-axis capability, this machine will fit in your shop. And the cool thing about it, as you can see here with this low door, is you have great access. So if you're loading and unloading parts, it's easy in this machine. Now, as we come around to the side, we've got a big side window here. And the reason this is designed in is we'll have the ability to add either an APL, an auto parts loader, or even a pallet pool to this machine. So lots of capabilities with all our UMCs. Now we're going to move just to my left, and Andrew's on the VF3YT50.
As Brian was saying, VF3YT. Now what's special about this machine, it's of course our medium footprint VMC. But in here you see kind of the star of the show here, 50 taper spindle. If you're doing lots of hogging, but you want to do that in a space that doesn't take as much as one of our really big ones like a VF8 or a VF10 or something. If you don't need quite that much table space and travel, then this fits the bill. 50 taper spindle, 30 pocket, 50 taper tool changer. Really, if you're getting to do some hogging, but you need to do it in a smaller space, this is the machine for you. Moving on, let's go to this one here. So this is our new long bed ST30. ST30 LY, Y-axis lathe in this case. And of course, you're gonna buy this machine because you need to turn long parts, or maybe you need to turn intermediate length parts, and maybe you want to do that with our steady rest. So you're kind of in one of two situations here. Either you're going to run a really long part in which you're going to support it by the tailstock, or maybe you've got an intermediate length part that you're going to support with your steady rest for doing deep hole drilling and end work on that shaft. Very easy to move the steady rest back and forth. But another cool thing is, let's say I've got this little part in here. Now, if I've got a part like this experience is pretty much just like running a regular ST30. If I'm running a short part, this is going to be the same as when I'm running an ST30. So that's really nice. Another cool feature about this machine is you can see this hole here, if you will. This is what we call the extended Z pocket, and this gives you a lot of clearance for boring bars and other really long tools, so that you can still get all the way up here to turn on the face of your part, and you're not gonna hit those tools against the bulkhead here. So ST30 long bed, great machine. Let's move on over here to this to the APL. Now this is another example of how to put automation to work in your shop for a really reasonable price. Here we're marrying our automatic parts loader up to the ST15Y. So you've got Y-axis capability on this small footprint lathe, and then you're going to auto feed those parts, auto load those parts here from this table using this arm, and kind of like the robot allows you to. In fact, our programming process is very similar to how it works on the robot. It really started with the APLs. All of that is controlled from within the Haas control here. So you use a series of VPS templates. It just walks you through. I've got these GIFs on screen here to show you what you need to do. And then to jog the machine, you're going to use the remote jog handle, in this case our new touchscreen one. So it's very easy to move the APL arm into the position that you want to program, turn on APL mode, and the thing works automatically. If you don't need it to work in that mode, you just turn that off and use it like a regular lathe. Pretty straightforward. Let's throw it back to Brian.
All right, now we're at the CM1. CM stands for compact mill, and you can see why. Small little machine. This is an ISO 20 spindle, 30,000 RPM standard with a 50,000 RPM optional. So obviously when you have small tools, you need that higher RPM. This machine has it. Automatic tool changer, and this is primarily medical, dental, aerospace, somebody doing some prototyping. Great little machine. Obviously it'll fit in a small space, and the cool thing about this is this can run on single phase power. So if you're thinking about putting this in a medical or a dental office, you don't need 3-phase power. Okay, right next to the CM1, we've got the mill version of the APL. So the same great programming method that Andrew talked about. Everything's programmed through the Haas control using VPS templates, the remote jog handle. Little different configuration. We've got the 2 grippers, one for loading and one for unloading. Same great programming features. And we've also got an air vise provision in here. So obviously when you're running unattended, you're not going to be opening and closing the doors. Auto door, air vise, complete unattended operation. We're going to move to my left, toss it back to Andrew, and he's going to talk about the TM1.
Alrighty, TM1P. Now, the TM1 and the TL1 are machines that are equally at home in a production environment, or maybe more in a school environment, or kind of a inside your garage kind of environment. Really what these machines are about is introducing CNC machines to someone who's coming from a manual machine background. If we see here, This has got the table and the layout very similar to an e-mill, Bridgeport style machine. But this is a true full CNC machine. In this case, this is the TM1P is kind of the slightly improved version of the TM1. TM1 comes at about $31,000. This is $35,000, and for that extra $4,000, you get a lot of bang for the buck. You've got a 10 pocket tool changer, a faster 6,000 RPM spindle. It's really, this kind of takes it from a more manually oriented kind of experience to really a full production CNC machine. This is just a step away from our VF2 style of VMCs. All right, let's move over to the TL1. This is kind of the same concept here. If you're coming from a manually controlled lathe, then this layout's gonna be very familiar. Chuck's right here, steady rest, cross slide. The basic version of this machine comes with a single tool post here. But in this case, we've got several options of this machine. We've got the E-hand wheels is what we call them. This is kind of a manual method for jogging these axes around. You can see here, I can jog these very much how you would in a manual machine, but you can also run this in full CNC mode. And that's the beauty of it. If you want to approach it from a manual perspective, that's easy. And also when you're ready to move on to controlling it via CNC, it works great that way as well. And you've got the same style of VPS templates here. I can do a whole bunch of different kinds of features here. All I have to do is enter the important aspects of my part geometry into one of these templates here, and the VPS templates will output a complete program, and I can run that. No need to know G-code to start with. So, TM1, TL1, both aimed at getting a manual machine operator used to using a CNC. Let's throw it back to Brian here on the CL1.
Okay, I'm at the CL1. I talked about the CM1 earlier, the compact mill. CL1 stands for compact lathe. And again, you can see why this machine also can run on single phase power, so that's important if you're running in a small shop or a garage or if you're a beginner. But this machine has a lot of fully production features. So let's come under the hood here. First of all, this machine comes standard with an 8-station turret. And in this case, this machine has a couple of really cool features. We've got a little parts catcher here, and we've even got live tooling. So you can add a bar feeder. So we've got 2 different lengths of bar feeders. So if you add a bar feeder, you put the live tooling and a parts catcher on here, you can run this thing fully in production mode. Of course, you can also run it as a chucker lathe and make small parts. Okay, let's go right next door here. And this is what we call the desktop mill. Let me open this guy up here. So this is a fully functional CNC mill. And the great thing about it is, even though it's limited on travels, it's not really a metal cutting machine. It's designed for wood, machinable wax, things of that nature, plastic maybe. It is a full CNC machine in the sense that this is not a simulator like you're used to a Haas simulator. This is actually a full-blown control. So if you learn how to program this desktop mill, this same programming applies to a VF2, a DT1, a UMC, any of the machines that we've shown you here. So really geared for beginners and in particular schools.
Thanks guys for joining us on this tour of the demo room. We've looked at small machines, large machines,
all the way up to 5-axis machines, a 50 taper,
Haas robot package, everything in between. So we're going to do more of these factory spotlights. We appreciate you watching, and join us next time for some more of the Haas factory. Thanks.
Hi guys, I'm Marcus Imes. Thanks for tuning in again. I want to show you around one of our most popular new products, the desktop mill. It's our most compact and economical way to learn the Haas control and 3-axis CNC programming. We designed the desktop mill to be the next step up from the Haas control simulator as a training tool. Although the control looks like a simulator, it's actually the exact same full-featured control you'd find on any of our other machines, like the VF2 over here. I want to show you how easy it is to set up the desktop mill and use VPS conversational programming to generate some code. So you can see here, I have a couple blocks of plastic on the table to work with. We mostly recommend cutting plastic or machinable wax on this machine since the material is cheap and reduces damage if a crash occurs. Or, for the ultimate in simplicity, we offer the spring-loaded pen attachment, which mounts directly in the spindle. Then you can put a clipboard and a piece of paper on the table and use the desktop mill to draw shapes with CNC code. But today, we're going to make some chips. So, I have my 1/8 inch 3-flute end mill, and I'll tighten this in the spindle. I should mention the spindle has a permanent female ER11 collet interface for the spindle nose, so you'll need a set of ER11 collets for each machine. Now, I'll tighten my tool in the spindle. It's a small tool, so don't over tighten it. Next, we need to give the machine some Z geometry. So, we'll set our Z-axis offset to the top of the stock to establish my Z height. I have a piece of paper here we'll use as a shim to pinch between the tool and the workpiece. Now that I've made contact between the tool and my workpiece, I'll use this as my work offset for my tool. Now, I'm going to set my work offset. I'm going to hand jog the spindle to where I want to set X0, Y0, and then set my G54 work offset. So let's do that. Move up Z a little bit. And I'm just going to eyeball this, but if you wanted to be more accurate, you could use an edge finder as well. So I'm going to set my X0, Y0 where I'm at right now. I'll go over to my offset page. From the offset, I'll hit F4. And in this case, looks like we already have some numbers in G54, G55, so I'm going to use work offset G56. I'll push part 0 set for X and again for Y. And I'm going to leave Z blank, although on most of our machines you would set a Z work offset. Here, all of my Z geometry comes from my tool, since there's no tool changer on this machine. Now that I have my X, Y, and Z established, let's go to VPS and make a short program. You can find VPS under the Edit button, then tab up to the top and over to VPS, and then go down to the VPS, and we'll go over. As you can see here, you have a few different shapes we can easily make, like bosses, pockets, drill patterns, but today I think we'll do a little engraving. So let's see what it takes to operate one of the VPS templates. These are all composed in a very similar manner, and basically you're just answering questions from top to bottom. We have useful pictures that help determine what inputs we're looking for, and we have some help text down here. So the first thing it's asking for is our work offset. By default it chooses G54, but if you remember, I set G56. So I'm going to enter 56 and enter button, and now we're using offset G56. Next, it's asking for a tool number. I can tell we are currently using tool 2 from the offset table, or from the memory screen, it also tells me tool 2 is currently active. I'm going to leave that alone since we don't have a tool changer, so 2 is a good number. Now it's asking for my spindle speed. How fast do we want the cutter to turn? I have a valid range of 50 to 24,000, so quite a bit of range in there. I'm going to choose 5,000 RPM just from my experience, and I know that that won't be too fast for this machine. Since we don't have coolant, I don't want to melt the plastic, so I'm going to select 5,000 and press enter. Next, I need to give it a feed rate. How fast do we want to move? Well, how do we calculate that? Since I selected 5,000 RPM, and I know my end mill has 3 flutes, and I know a good chip load for this plastic material is 2 thousandths per flute, I take 15,000 times 0.002, which would give me 30 inch per minute. So I'm going to enter 30 with a decimal, because this one requires a decimal. Next, M8 is asking coolant or no coolant. This is a code all new machinists will learn very early on, And this is one way that VPS reinforces codes where applicable. So if you're choosing a canned cycle or like coolant on, coolant off, we're going to reinforce that with the actual M or G code in the template. In this case, we don't have coolant, so I'm going to enter 0. Now it's saying, where do I want to start? Since I positioned my G56X0 at the position that I want to start engraving, I'm going to leave this one as 0. But I am going to move Y up about 100 thousandths to get us off the center line of the part. So I'm going to enter 0.1. Now here is my rapid plane. The rapid plane is where the tool changes from G0 rapid approach to a G1 feed move. The default we have in there is 100 thousandths of an inch. I'm going to leave that alone because that's a pretty industry standard number. Now it's asking for my Z depth. How deep do I want to cut? I know that this plastic top, the red plastic on the top of this part, is 50 thousandths deep. So I'm going to say give it a value of maybe 70 thousandths, so we cut down below into the white. Now we can do either text or serial number or a specific number if we wanted to do that. In this case, I'm going to leave it 0 to select text. And we could, it's asking how high do I want it. A ½ inch looks good to me. And do I want it on an angle? In this case, no, I'm going to go straight across, but you could also do it at any angle around the circle. And now at the bottom, what do we want to engrave? How about HaasTec? And that's the last line of this template. So from here, we can do a couple things with it. If you notice up here, we have generate code with F4. So we can copy it to the clipboard if we wanted to paste this into a program. I can output it to MDI, or I can create a new program with it if I don't already have one established. In this case, I'm actually going to use the fourth option, which is just pushing cycle start, and that will run the template directly from this page. But before I do that, I'm going to move my machine away from the stock a little bit. In case I entered any bad numbers, I want some time to push stop. So let's do that. So first thing I'm going to do is move Z away from the table a little bit, just in case I got anything wrong. This will give me some time to realize that and stop it before I crash anything. So I'll go back to my VPS template. I'm going to change my rapid down to 5%, and I'll hit cycle start. Once I'm confident it's moving in the right direction, I can change that rapid override to a higher value. Now since the desktop mill doesn't have a tool changer, the first thing it's going to do is move to the back corner to a safe position and ask me if the right tool is loaded in the spindle. This way you can make a program with multiple tools even without a tool changer. But since we already have the tool in the spindle, per the message on the screen, I'm going to push the letter K to continue. And now I'm going to change the rapid override down a little slower. Now that we're moving in the right direction, it looks like. Speed it up a little bit. And just to make sure I got all my heights correct, I'm going to stop it just before it gets to the material and look at my distance to go screen. So I'm going to press position and then tab over to distance to go. I see I have 49 thousandths, which looks about right. If that number was drastically different, that's your first warning that something is wrong and you should stop and double check everything you've done. Now that I've verified my distance to go is good, I'll press cycle start and continue. So, I think you can see why there's a lot of excitement around the desktop mill. It takes a full-size machine's capabilities and shrinks it down to about the size of a mini fridge, but still allows hands-on setup, programming, and troubleshooting experience which directly translate to our full-size machines. Check out HaasCNC.com to get a custom quote on your own desktop mill with our build and price tool today. Thanks for joining us.
Good morning, guys. We're here in Oxnard, California, at the Haas factory, and today we're going to give you a tour of pretty much the whole facility. So let's go in through the front entrance here and get started. All right, so this is the main entrance, of course, the lobby here. Now we've got racing memorabilia on each side from all of Haas's race teams, but we're not going to look at that right now. Demo room's over there. We've got another video that covers that. Right now, we're headed towards the machine shop. We're here in building 1, of course. We've got 4 buildings on campus here, totaling over 1 million square feet under roof. And we're gonna start in building 1 on the machine shop side, as I just said. Right here, actually we're on the other side of this wall is rotary assembly. We'll be coming back to that quite a bit later here in the video. Right now, we're headed towards the machine shop side of building 1, and this is where we house a lot of our FMS systems. So, building 1, machine shop side. As you can see here, we've got some rotary table bodies. We're surrounded by them, actually. HRT 1000, our largest rotary table. TRT, rotary bodies, and trunnion castings. HRT 310s, 210s, 160s, runs the whole gamut. But on this left side here, this is kind of what we're going to focus on for right now. All throughout the factory here, we have a variety of different FMS cells, or flexible manufacturing systems is the long name for them. Right here we've got these Machinos, several Machino cells tended by these pallet walls here. And really this just signifies Haas's investment in the right tool for the job. We've been using large FMS cells since before I started in 1997. So the concept and reasons are well founded. But we continue to make new investments in these systems because it's the right approach in some cases. People ask, why aren't you using Haas machines throughout your entire factory? And the simple answer is, these large HMCs and pallet stackers are not the market segment that Haas is building machines for. But it is the right tool for the job in this case. A high mix of parts at a medium volume makes these pallet stackers ideal. The concept is simple really. Machine the right part at the right time here in the machine shop so that part is ready to put together on the assembly side of the factory when it's needed. And keep these spindles turning as much as possible. All right, so we're leaving this, the Makino FMS cells. We've also got some Japanese ones down that way. We'll probably see those on the B-roll. Anyway, you can see we got lathe turrets here. Rounding the corner, we're gonna head down this aisle here where we've got a whole line of EC400s. Now these are our earlier version, not the present one. Most of these machines were installed between 2012 and 2014, so 6 to 8+ years old. Now, this is kind of an example, well, this is completely an example of how Haas does the same style of machine as those FMS systems we just looked at. But in this case, it's geared towards a medium-sized shop at a much more affordable price level. But the idea here is that these horizontals are aimed at getting a high mixture of parts, or maybe you're focused on one specific part. All of these cells are mostly concentrate on 1 or 2 parts or a few parts where we're doing very high volumes. But you can see, when you attach a pallet pool like this to one of these HMCs, you've got a lot of fixture positions. And the idea is, with the pallet pool loading and the pallet changer loading those pallets in and out of the machine continuously, your spindle on time is maximized. You can see right here, we're making motor housings for our machines. Just one example of all the different parts we make on this line here. All right, so we're right next door to where we just looked at those EC400s. Now you can see we've got this line of BMC 1000s. These replaced older models just recently, but the idea is the same here, just from much larger parts. Each one of these machines has 10 pallets, and you can see we've got a variety of different castings. We've got saddles, bases, just a huge part mix, but on these huge 1,000mm pallets, the focus is large parts, of course. All right, moving on from those FMS cells, this is one of our 2 cylindrical grind areas. We've got kind of a variety of robot loaded and manually loaded cylindrical grinders. And you can see right here, we've got a robot tending this Studer grinder. They do spindle shafts, of course, all the different kinds of shafts, transmission shafts. As you can see here, we've got large variety of different output shafts, transmission shafts. Anyway, let's head around here. More cylindrical grinders. And then right past these machines here are our gear hoppers, and we'll take a look at that in a minute. But let's head this way. Over here, we have this giant, this is our newest gear hopper here, this giant modal gear hopper. And we bought this primarily to focus on the largest rotary gear sets that we make. Now you peek in here right now, this is an HRT 310 gear, if you want to take a look in there. But really, this is focused on HRT 600, 800, and 1000 rotary table gears. So really large gear sets. Anyway, huge gear hopper. Now over here on this side, we've got really the bread and the butter of the gear hoppers here. These focus on HRT 160, 210, 310, and up gear sets. And the thing here is, these are, you know, we've got millions of dollars of machinery here, but it's not just the machines. You can't put these into your shop and expect to be making high precision gears that fit perfectly and yield really good rotary accuracy, you know, a week later. You also have to have the crew of professionals that have all the wisdom and the knowledge to make those machines run correctly. And that's what we've got here. All right, this is our inspection room here. Considerably quieter than the rest of the factory. This is just another example of Haas's commitment to quality. We've got a huge variety of measuring tools in here, but probably you'd say the star of the show are all the different CMMs we've got here. This largest one is 3 by 1.5 by 1.5 meters. Use this for measuring our largest castings. We have a variety of other measuring tools. We do something like 15,000 tools that we calibrate every year. Gear checkers. Anyway, all kinds of cool stuff in here. Well, let's head this way for now. All right, so here we're standing in front of these giant MPCs, focused, of course, on huge parts. We've got UMC bases behind us, big SD50 base here. Anyway, you can see that these are pallet-fed machines as well. You can load your part here. You can load your part here while you have another batch of parts running on the machine. So it's kind of the same idea as the other FMS systems, just for much more massive parts. All right, we're just leaving the machine shop side of building 1. So we've just done one half of building 1. We got a long way to go. But out here, it's kind of an example of, you know, just the basic infrastructure of the factory. You can see here we've got compressors, and we're looking at about 650 horsepower, something like 2,700 CFM of airflow. That's quite a bit more than your standard shop. Past that, we've got our coolant recycling area, and on average, we're recycling about 3,000 gallons of coolant every month. We evaporate the water and then recycle all the used oil, of course. Also here you can see our propane area. This is where we have all the propane tanks to fill up the 200 or more forklifts we have driving all over this place. And then you can see these castings here. Anything that's marked with red like these are our first article castings coming in from inspection from our casting vendors all over the country and all over the world. So let's keep moving. We're gonna go head on over to building 2 to look at some more of our machine shop. All right, so we just walked into building 2, and this is of course the machine shop side of building 2. In fact, all of building 2 is pretty much machine shop now. Behind us are, of course, more FMS cells, and really it's the same story. We use these to build a high mix of different parts. On this side, these machines are mostly concentrating on aluminum these days. But the idea here is that overall in this machine shop, we have about 60 machines dedicated in FMS cells and over 1,000 pallets. So I don't know if it's the biggest in the world or in this country, but it's huge to say the least. All right, so we've left the area with the FMS systems. Now we're back over in another area devoted to really large machines. This right here, this VB3 from 2005, I think it is, you can see is still being used. Right now we've got an EC 1600 table sitting on here. They've got a rotary control box hooked up to it. Not sure what they're doing, but they do kind of one-off stuff on that machine from time to time. And then right here we have more of the older MPC double column machines, focused of course on the largest castings. These have been here for a long time, but still chugging away. And then on this side, we've got these Akuma MCRs. This is just essentially a newer, a little bit more sophisticated, quicker version of the same thing. All of these machines, of course, are pallet fed. So you've got a part waiting to go. You've got your part being machined, and then as soon as it's done, it moves out of the way and you load another one, so you're maximizing spindle on time. All right, this is going to be the last FMS that we'll look at today. This here is one of the largest FMS systems in the entire world based on the number of load stations and the linear number of pallets involved. Here we've got a really large mix of parts. You can see all the castings up there on the pallet wall. Lathe spindle heads, lathe gearbox housings, tailstock housings, just a really wide variety of parts, all made basically just in time for the production line. So now we're entering an area that's filled completely with Haas machines. As you can see on this side, we've got one of our robot cells. This cell is dedicated to building columns, just VF1, VF2 columns, very high volume. In here we've got 4 of these cells with E6 1600s tended by robots. We're building columns over here, tables and saddles over here, saddles over here, saddles there as well. So these cells are all dedicated to making 1 or 2 parts at very high volumes. These are machines responsible for keeping our small and medium VF casting lines running continuously at really high volumes. So now let's head on to this side. So all of these cells use 260 EC 1600s manned by a robot in the middle. On this side, we have a different configuration. This is typical of our other kind of robot cell. Here we're usually looking at 2 lathes and a mill tended by a robot in the middle. These are mostly focused, of course, on making round parts, spindle shafts, a variety of round other flat parts. So this cell here is an example of one that's dedicated to just 1 part. These are 40 taper spindle housings, of course. We go through a whole bunch of these every day, probably upwards of 50 of these a day right now. So this cell is dedicated just to making those. Now let's head back this way. We're going to take a look at what we call our batch production area. And that's just a big group of Haas machines dedicated to making a whole variety of different parts, mostly on the mostly smaller parts, turned and milled parts. Let's head over here. So this is what we call the batch production area. This is really the area of our shop that's the closest to a regular job shop. We've got a variety of mills and lathes. This particular area is a little bit near and dear to my heart because back in another lifetime here when I was a manufacturing engineer, these 4, actually most of these machines here, but these particular super speed VF2s, a little bit older, these are all around 2008 we put these into place. And at that point I was the guy that was responsible for doing the factory floor layout, making sure these machines came into place and older ones got moved out in their place. But you can see here we've got a testament to how long these things run. These have all been here for 11, 12 years or so, running non-stop. So let's head back out of here. And just like a job shop, this area is really focused on doing shorter runs of parts, stuff that the line needs right now. Now we're going to head from here and we're going to actually finally leave the machine shop and we're going to head towards assembly. Okay, so on the left here we have electrical assembly, and we've pretty much divided this area up into two different distinct areas. This is the control cabinet assembly on this side, and then over the wall we've got electrical sub-assemblies. But here you can see control cabinets that are partially assembled. Here's one we're looking at. We got our vector drive, the amplifiers for the various axes, main con board, I/O board, all that good stuff. Here's where the incoming power comes in. So we test these here, of course, as soon as they get powered up. And then when we get to the assembly line, when we put those control cabinets on the machines, we test them again there from the point at which you're doing the squaring, as soon as you can move the axes, all the way through till final assembly when we're doing the test cut and all that sort of stuff. Okay, so we're leaving electrical assembly. Now we're getting into the actual assembly area where we put the machines together. On this side, we've got large VMCs, and on this side, we've got UMC assembly. We call these the cast assembly areas. This is where we put the foundation of the machine together. If you look at this VMC, for example, right here, you can see we've got the base, saddle, table, column, spindle head, and we put these machines together all in quite a similar way, really. It's what we call the stacked axis method. It's pretty simple, really. We start with the base on the ground, lay down the linear guides, then the saddle, then the table. Typically, we build the column offline separately. We'll put down the linear guides and ball screws there, and then we'll attach the spindle head to that, and then we'll lift that column assembly and put it onto the base. And there you've got your entire basic machine assembly ready to go. Then from that point, it leaves this casting assembly area here, and we move on to what we call the final area. So this is the UMC final area. A few years ago, it was only the UMC 750. We've got one of those right here, of course. But these days, we've got the smaller brother and the larger brother to the 750. That's probably UMC 500 right here. See, this is a little bit smaller, small footprint. Moving from that to the biggest one we're offering now, this is the brand new UMC 1500 Duo, in this case an SS version. Here we've got the trunnion rotary table and a VF2 table. So you've got two complete different work envelopes you can take care of. Lots of possibilities here. Let's go across the aisle. Now we've got, over on this side, we've got UMC 1000 SS. So the super speed big brother to the 750 and the 500 right here. So of course, when we come to the final line, the idea here is after the casting assembly is done, here in the final line, we take care of the geometry of the machine, aligning all the axes. Then we put on the sheet metal, install the control, and then do all of the testing that goes into making sure that the machine is ready to go. Okay, so leaving the UMC area, now we're entering where we build all of our EC machines. This is our brand new EC500 50 taper. And we're gonna be looking at this later in the show, but brand new machine, just released. This, I believe, is the first one. Right beside it here is one of our EC400s, pretty much in the same stage as those other machines we saw. Here we build these machines all in one spot. We don't have a casting area and then a final area because the production levels are lower, and since they're even larger, we typically like to just leave them in one spot and bring the sheet metal to them as we assemble them. Now let's walk through. This is where we build our GR gantry routers and our GM gantry mills. You can see this right here, GM2 5AX. Got this 5-axis head on here. This has got the extended Z travel. Super capable machine for doing really large 5-axis parts. So now let's go leave this GR area and we're gonna walk straight back over here. So now we're in the VMC, large VMC final area. And this machine is an example of one that's in the middle of getting the geometry checked. It's kind of the same for all these different lines. You get this machine out of the casting area and you're gonna line up all the different geometry of the different axes, make sure everything's square, perpendicular. And then from there, you're gonna start installing the sheet metal, and then it goes through the whole plethora of different tests leading up to the final test cut. Most of these, yeah, you can see we have some machines that are enclosed down there getting ready to be test cut. So these cells here are an example of how we do kind of medium volume, medium-sized castings and keep the spindles turning as much as possible. Here we've married up, we've got a whole bunch, like 7 of these cells, and typically it's a VS3 married up to one of these Lathes pallet changers. So here's the pallet changer, and up here, of course, is where the machining is happening. So we've kind of run 2 different things here. Medium-sized lathe bases, small lathe bases, and then on some of the other cells we run medium and small VMC castings. So let's go walk down this aisleway here. So we've been running these VS3 cells for easily more than a decade here. But more recently, we've teamed those up with these Lathes pallet changers. And it's the same idea as we see on even the FMS systems and any of the EC400s. You're carrying multiple parts so that you can keep the spindle turning the entire time. You've got one part staged, one part being machined, so you keep that spindle turning. Let's go through here. We can see more of these pallet changers. Here we are where we're getting ready to load these small VF bases onto here so that machine will run those. Now let's leave this area here. Got one more thing I want to show you before we leave this building. Here we have 2 cells dedicated to making just the side mount tool changer cams. And we used to have EC630s that were custom modified, making these castings. So quite a sophisticated machine. And these are sophisticated, but it's kind of a more simplistic approach. If I come in here, you can see this is just a VF3 with a customized TRT 210 rotary table on here. It's just essentially an offset platter mounting, and these cells are dedicated to cranking these cams out all day long, every day. Got another one right over here, and that's just because we make a lot of tool changers every day. let's head this way. We're gonna take a quick walk through the casting yard here. Okay, so we're entering the casting yard here, as we call it. This is a favorite for when we're doing real live tours, of course. Now, this is where we hold the bulk of our castings before they get machined. As you can see, we've got castings on every side. Large VMC columns over there. Small, medium bases here. Let's keep walking this way. More medium base castings here. We're looking at around 7 million pounds a month right now. 350,000 some odd pounds of cast iron machined every day here. We get our castings from pretty much all over the world. USA, Canada, China, Thailand, India, Poland, and all of those castings go through the same rigorous inspection here. They all have to meet the same specifications no matter where they're coming from. So as long as they meet the specifications, we're good to go. Here are some, some more similar castings. We have UMC castings back there, UMC 750 castings. Here we have EC 400 base, runs the gamut really. And what's crazy is that all these castings here, this is about a 1 month supply. We'll turn all these castings, or pretty much all these castings, over every month. So it's a huge amount of cast iron we're talking about. Let's keep walking through here, and we're gonna head to building 4, our inventory building, and take a look at the huge pallet racks and the narrow aisle equipment over there. Let's head this way. So this is building 4. This building houses all the inventory for the entire factory. So in a second, we're gonna see all the inventory racks. But right here, you can see we're actually doing assembly work here. This particular line is dedicated to small and medium enclosure assembly for the VMC line. It's our highest volume line. So we put them together here, roll the motor to building 1, just a more efficient way to put together these large enclosures. Let's keep going this way. Now we've got kind of a mix of regular width aisles here, and then as we'll see in a second, we also have narrow aisle equipment, just to get more density, of course. We want to store as many parts as possible. We store literally tons of sheet metal here. Sheet metal is really the biggest space hogs, if you will. So we store a bunch of it here. In front of us here is where all the incoming inventory is handled. We typically fill and then clear this area 3 times a day. We've got some nearly 700 vendors worldwide, so all of that inventory is coming in onto this dock and then disseminated into these pallet racks every day. So in this building, we've got 34-foot high ceilings, 10 feet higher than any of the other buildings in the complex. We have precision flat floors with guidelines in the floor for use by the narrow aisle fork trucks. When we were putting this building up, we used 1.5 million pounds of pallet racking, and that gave us 17,000 pallet spaces. We have more than 20,000 different part numbers in this area and over $50 million in inventory. Typically, we're looking at about $1.5 million a day coming in from our various suppliers all over the world. As I said before, we're somewhere around 675 suppliers worldwide. We're looking at typical inventory levels of 10,000 ball screws and 30,000 linear guides at any time. We stock components from THK, NSK, Bosch, Ina, Steinmeier, and SKF. Our total consumption of these 2 critical parts is around 33,000 ball screws and about 87,000 linear guides every year. So this is the service parts shipping area here in the factory. This is kind of on one side of building 4 here. You can see these are all orders going out to our dealers. We hold about $10 million in stock here, and that's in addition to the $75 million or so that are held at all the HFO consignment stocks around the whole world. The idea is for dealers to ship service parts from their warehouses or to have those actually in the service vans that are going to the customer shops. But whenever that isn't the case, we're shipping those parts next day from here. And typically, we're maintaining a 99% same-day shipment. And if you go to our service webpage and you page down a little bit, you'll see that we actually post what we're maintaining service percentage shipment-wise every day. And typically, we're above 99%. Pretty amazing. That means that if a customer needs a part, they're gonna get it as soon as possible. So we're headed back towards building 1. We're going to end up finishing up on the building 1 assembly side of things. Just left building 4. But I just wanted to mention here, this is what we call our freight consolidation area. Most of these machines are headed overseas, but sometimes we even gather together larger shipments that are headed to the US. But the idea here is large groups of machines all headed to the same HFO that we want to group together in one shipment. So we've got machines staged here going all over the world. Who knows? Maybe one of these machines is headed towards your region now. But for now, let's head back to building 1. We're going to take a look at assembly. All right, now we're back at the very front of building 1. Actually on the other side of the wall where we first walked in at the beginning of this tour. Now, this is the rotary assembly department. Rotary tables and indexers, of course, is where Haas got its start. Nowadays, we're surrounded by a lot more than just the basic indexers and rotary tables. We can see TRTs on this side, trunnions on this side. Here's some more of the typical stuff, HRT 310, HRT 210s and 160s. If we keep going this way, here we have a whole bunch of rotary tables getting ready for shipment. And it's easy to see why Haas Automation is the market leader in rotary tables and indexers. All right, so we're coming from rotary assembly into VMC assembly, and that's probably fitting because that's basically the progression that Haas followed from rotary tables to vertical machining centers. So this is the cast assembly area, and this is actually this assembly line, what we call a flow line. We just put it in place recently. Really, this is just a more efficient way and maybe a little more consistent way to put together VMC columns. In this case, small columns. This is our highest volume column assembly that we make here. You can see that this is kitted, ready to go, so that once it's assembled here, it's taken over to this side. This is where we do the entire stacked axis method we were talking about earlier. We place the base on the ground, add the linear guides and ball screws, install the saddle and table, and then we take that column assembly that we built over here, lift it with a crane, drop it onto the top of this guy here, and you essentially have the bare bones of the machine. Then we take this finished bare bones machine here, and we take it across the aisle, and we head into what we call final assembly. And here, we finish the geometric alignment of the machine, make sure all the axes are square and everything perpendicular, and then we start installing sheet metal. You can see these machines here. This machine, of course, is just about ready to ship. You can see most of these machines are getting ready for shipment. In fact, this one's being cleaned up, prepared for shipment. This will probably be going out later today. Now, we're going to keep going. We're going to leave VMC assembly and head towards lathe assembly. Okay, so we've left VMC assembly. Now we're entering the lathe assembly area. As you can see right here, we have some assemblies that are getting ready to be put onto this line. Wedge assembly here with the turret attached, all ready to go. Over on this side, we have spindle heads ready to go on the line. Another wedge assembly. Now, over to my right-hand side here, this is where we put together the small lathes, SD20s. And then over on my left-hand side, this is where we put together the ST30s. Now, similar to the mill line, we have a cast area and a final assembly area. This is the cast assembly area. Kind of the same idea here. You place the base on the ground, put down the linear guides and ball screws, and then you start adding all the large sub-assemblies. In this case, let's get back to this one here. Now you see here, we have a base casting where no assembly work has been done yet. Just getting ready, they'll level this out, then they're ready to put on the ball screws and linear guides. Right here we have an assembly that's progressed along a little bit farther. This is the bare bones spindle head right here. Here's our wedge assembly and the turret, tailstock. These are kind of all the main components that need to be on this lathe to turn into a functional machine. Ball screws, linear guides, everything's been installed. From this point, they're going to attach the control, and then they'll start building the sheet metal around it after they've made sure everything geometrically is moving correctly. Let's go from here down to the final line. So here we are on the lathe final line. This, of course, is the small lathes, SD20s, 25s. This SD25 is, well, looks like it's almost ready for shipment. It'll be completely final packed up in a minute here. It's running the last series of tests, just kind of exercising the control and the axis motion. Once again here, I'm beginning to sound like a broken record, but here in the final area, we put on all the sheet metal after the geometry of the machine has been set, then we install whatever options are attached to that order, test those, do a final test cut, and the machine's ready to ship. It's going to go from here out to our shipping area. Let's take one more walk and finish up in the shipping area. All right, here we are at long last at the back end of building 1. This is the shipping area here at the factory. And this is of course where all of those machines and all those different assembly lines end up. And they get packed for shipment to an HFO near you or a machine shop near you. We'd like to thank you for joining us on this whirlwind tour of the factory here. And we really hope that the next time you're in town, you can join us here for a real live tour. Thanks for joining us, and we'll see you next time.
Hi, my name is Milton Ramirez. I'm going to talk about the Haas control today. The Haas control has been designed for user friendliness over the years. Since its introduction in 1988, the Haas control has been basically the same layout from day one. So I want to talk a little bit about that because the Haas control is, I believe, the easiest control to learn out there in the industry. A student can come and spend a couple of hours maybe with an instructor on the control and learn how to manipulate the machine and all the basic operations fairly quickly. So basically the Haas control is made up of sections, right? The first section I want to mention is the function keys. These are used in many different displays, many different pages, and as their names say, they have different functions assigned to each one of them. The next section is called the display section. This one allows you to navigate around the different screens or displays on the Haas control. Next, we have what we call the mode keys, right? It's basically 6 modes. Those are the common modes that every single control out in the industry has, which are used to operate the machine. We simplify, each mode by having a row of buttons that pertain to that mode. When I say modes, I mean edit mode, memory mode, MDI, manual data input mode, handle jog, zero return, all the common functions and modes that the control has. Okay, next would be this larger section, which is what we call the alphanumeric section, right? This is what you use to type all your data when you're programming something manually, when you're entering information in our visual programming system. Okay, next you have the override section. This is where when you're running a program, it allows you to actually use these keys so that you can speed up the spindle as necessary, so you can later adjust your program. Also, you can override the feed rates. You can also press this button here, and you can use the handle to increase or decrease your feed rates or your spindle speeds. So after that, you move up a little bit, and then we're going to have the jogging keys. These are keys that you can use to jog the axis manually, so you don't have to spin them this way, or if your machine comes equipped with the remote jog handle, you don't have to use the handle. You can just simply stand here by the machine, look at what axis is moving. You can even lock it if you use this middle button before you press the axis key, and the machine will jog automatically. There's a couple of other buttons here, the blue buttons, that are actually buttons that you use to turn on and off the chip conveyor, on and off for the coolant. You can move the coolant spigot up and down. So basically, those are the actual zones or areas of the Haas control. As you can see, it's very simple. It's not intimidating. It's easy to get around. It's pretty understandable. So I'm going to demonstrate a couple of buttons that we really like on the Haas control. The first one is called the power up button. That is a one-touch, one-push button that zero returns your whole machine. It doesn't matter if it's a 3-axis mill, if it's a 2-axis lathe, if it's a 3-axis lathe, if it's a 5-axis mill, it doesn't matter. The machine's going to do it automatically with one button push. I just press power up restart, and off goes the machine. It's zero returning the tool changer as well. That's why you can hear it moving in the background. But it's on a Haas control, it's only a few, maybe seconds, while all the axis zero return. When you come back to it, the machine's gonna be ready to go. I remember the days when I ran other machines, other brands, other controls, and maybe I had a problem with the tool change. I wasn't comfortable with the length of the tool over my part or whatever. I would press emergency stop and stop the machine in the middle of a tool change. That meant that I was gonna take a few minutes, maybe 10 minutes or whatever it may be, to recover from that. On a Haas machine, it's very different. Let me show you what I mean. I'm doing a tool change right now. I did a tool change with 2 tools in the arm, even a probe actually, so it's a little riskier. But I'm not worried about that because I know that I can come over here, I can clear whatever alarms. I pulled out the e-stop that I pushed in, clear the alarms, right? The tool change doesn't clear because there's a problem with it right now. But all I have to do is press recover, and the machine is starting the recovery process. As you can see on the control, it returned the arm to its position. It returned the pockets to their original position, and it checked the whole system to make sure the tool changer is good and ready to go. So now there's a pop-up window that says that I can close it. So I'll close it by pressing cancel, and my tool changer is recovered. I can test that by doing a tool change. No problem. So recovering a tool change from maybe a stop in the middle of it because you lost power, because you got startled and thought the tool was going to hit your part, whatever reason may be. But as you can see, recovering from that is one button push on a Haas control. I have an MDI, a program prepared for tapping. I'm gonna press cycle start. It's gonna call tool 1. The program is basically a tap. Well, my tool isn't a tap because I'm not really showing you the tool, but I want to show you what the control does, okay? So it grabbed tool number 1. It's gonna go to its position. It's gonna go to its Z offset, and it's gonna start tapping. There's many states where there's storms all the time in the United States, which means that it might be that in the middle of a tapping cycle on a very expensive part made out of titanium, stainless steel, whatever it may be, maybe you've spent hours on that part. So now what do you do when your tap is actually stuck inside your part because you lost power? Or maybe, you know, you just freaked out like a lot of people do and pressed emergency stop in the middle of a tapping cycle. What do? So Haas has developed a feature called tap recovery as well. So I'm gonna clear my e-stop that I pushed myself. I'm gonna press recovery again. And now you can see that what we have is a bubble that offers me the chance to choose between tool change recovery, which I don't need right now, or tap recovery. So for tap recovery, I'm gonna press number 2. That brings up a beautiful image here that explains that all I have to do now to extract that tap from my part is either press forward or reverse, depending on if your tap was a left-hand tap or a right-hand tap. The cycle that I programmed was a right-hand tap. So I'm going to reverse the tap so that the machine right now is actually reversing the spindle and it's moving in the Z-axis at the exact same feed rate of my tap, which means it's actually extracting it out of there. So I can keep going until the machine is basically all the way up on Z-axis. I would actually reverse it until it clears the part, but if you want to, you can stay there for minutes, right? So at that point, it would have cleared my part. I'm free to maybe zero return the machine now because, you know, I lost power. So, you know, you would definitely have to do that. But if I want to exit tap recovery now, all I have to do is press F1. As I said, a function key again, right? These are going to have many functions in different screens. F1 to exit tap recovery. Another great feature of the Haas control that I'd like to mention is that it has the manual on board on the control at your fingertips at any time. Let's say, for example, you're not sure about a particular G code or M code in your program. You can move your cursor or cursor down, right? You can highlight that G code or M code that you'd like to read more about or know more about. Once it's highlighted, press the help key. And what it does is it brings up the section of the manual that completely explains that G code or M code. So you can go, you can see what each address is on that particular G code. It explains, you know, as you know in the manual, every single entry necessary for that G code to work. After that, you can press F2 while you're in the manual, and that'll take you to the table of contents, which is really nice as well because then you have a bunch of information in a detailed format where you can actually choose what you want to know about the machine. Let's say, for example, there's some icons popping up over here that you don't really know what they mean. You can go and look up a list of the control icons that explain why each one pops up and what exactly it means. This is specifically to the next generation control. You can scroll down with this handle here, as I'm doing, and start looking at the icons with their explanation next to them. Okay, you can also cursor down with this key, or you can page down if you want to go a little bit faster until you find the icon that you'd like to read about. Okay, once you're done with that, you can press F2 again, and there's an actual programming section that you can go to. I'm selecting the programming section now. I'm pressing enter, and then it basically asks me what kind of program am I looking for? What kind of program examples? Special G codes, cutter compensation examples, can cycle examples. What do I want to look for? So let's say I open a can cycle section. Now that brings up drilling can cycles, tapping can cycles, boring, reaming can cycles, and then also a section that explains R planes, which is the retract planes, right? So let me look at the drilling can cycles, which are really common, a common operation on milling machines. And that brings up G81, G82, G83, even G73, which is the high-speed drilling pecking cycle as well. So I can read everything the Haas manual, operator's manual, has to say about those codes. And then I can go specifically to each one of them for more examples as well. Okay, the help button here will take you to the operator's manual that has all the information you're going to need for any question you might have at any given time during the use of your Haas machine. Let me show you one more thing on the Haas control that I think can make our lives easier as we work on these machines. Okay, the next one is what we call the device manager. Okay, if you go to the current commands display on the control with this button here, that'll take you to a display that has several tabs on top. The first one of them is called devices. And then right under that, there's a sub-tab called mechanisms. What that means, it's an area that allows you to directly go to where you can control all the mechanism and devices that are installed on your machine. A lot of them are going to be optional, and some of them are going to be standard depending on what machine you have, okay? But it's really cool to know that you have this here because let's say, for example, I want to orient the spindle for whatever reason. At some point, years ago, I would go to MDI and type M19 and press cycle start and orient the spindle that way, right? That was the only way I could do it. But now, if I go directly here to the device manager, there's a section there that says main spindle orient. All I have to do is press F2. That oriented my spindle right now. So I have access to all the devices that are on this machine. For example, tool air blast, which is a blast that comes out right through the spindle of air to clear all your chips. I can turn that on from here, but I don't have a tool right now that has the hole going right through, so that's why you didn't hear it below. But I can turn it on and off directly from here. There's also the mist condenser, which is that option you see right on top of the machine, right? That mist condenser, I can turn it on or off from here as well by pressing F2. It'll turn it on, toggle it, and F2 will turn it off as well, okay? Whatever you have will be displayed here, and you'll have access to that. Let's say, for example, if I was on a lathe and I go to the device manager, I can do a tool change from there. I can lower the tool setter from here. I can do spindle orientation from here. I can open and close the chuck from here. I can open and close the sub-spindle chuck from this device. Very, very useful. Let's say, for example, I'm on a horizontal machine with pallet indexing, like an EC400. I can actually do a pallet change from here by just pressing F2. That is, really, really easy, and it's reliable, and it's at your fingertips at any given time. If I had a pallet pull, for example, even then I can control the pallet pull as well. You don't have to look around anymore. You don't have to know commands. You don't have to know M codes. You don't have to know where the buttons are. Just go to the device manager and you have full control of all the devices and options on your machine. So let me show you something called the user positions, okay? To get there, let's go to the settings page. Once you're on the settings page, you're gonna have some tabs, as you usually do, because there's a lot of different things you can do from every display. So let's move over to the right to the tab called user positions. At that point, on this vertical mill, there's at least 3 positions that you can program, okay? One of them is the user travel limit. That one allows you to actually jog any axis on this machine to any position starting from home that you'd like. And if for safety reasons or for your particular part program or for whatever it is, the application that you're running, you want to limit the travel on that axis, you can. You can just basically jog to a certain position like I am right now. Then you go back to travel limit. I look for x-axis. Once it's positioned where I want it, all I have to do is press F2. Now that position is recorded. Now I can jog away from that, but I cannot jog past that. And as you can see, the table stopped, but I didn't get an alarm, which is cool, right? But I just limited the travel on that particular axis, okay? So that's what we call the user travel limit. So allow me to remind you that each one of the features and user settings that we've talked about here today also has a video that explains it a little further on our Haas YouTube channel. So feel free to go and peruse around and look, and you'll find a lot of good information on there where you can expand your knowledge on the control.
Hey guys, I'm Marcus Imes, Product Specialist here at Haas Automation. Thanks for joining us for another Apps Minute. Today I want to show you around the new TRT 210 and our pneumatic work holding option. As you can see, it's a 2-axis rotary that has plus minus 120 degrees tilt and 360 degrees rotation on the platter. It can be used with 3+2 machining, which allows you to complete 6-sided parts in 2 operations, increasing the throughput of your machine, or full 5-axis tool paths to make highly complex parts. I did some test cutting on the unit, and one feature that I really liked was the fact that we put an oversized brake on the tilt axis. Using an oversized brake means you can cut more aggressively without worrying about overpowering the brake or having to slow down to avoid chatter. We've given you a few different platter options for this unit to suit your specific work holding needs. You can see this one has the standard 230mm platter, which has 3 different bolt hole circles to attach your work holding. If you need maximum fixturing flexibility, consider the optional 210mm T-slot platter. It has 6 equally spaced T-slots and allows for easy fixturing of a variety of work holding like chucks, vices, or toe clamps. If you need to get maximum throughput out of your machine, the new 0-point platter system is your answer. The 0-point receiver is permanently mounted to the rotary, and the machinable aluminum top plate can be quickly swapped out. You can buy extra top plates so you can stage multiple work pieces ahead of time and then change them out with a few turns of the wrench. The system is also extremely flexible and beneficial if you run a family of parts and do many program changes frequently. With the quick change platters, you can say goodbye to indicating multiple fixtures and losing all that setup time. With the 0-point system, you just load the correct platter, load the program, hit go. Last, if you want to permanently attach a chuck to the rotary, we offer the spindle nose platter, which has an industry standard A1-6 spindle nose that is compatible with a wide variety of 3-jaw and collet chucks, available from almost any third-party vendor. Another option available for the TRT 210 is the pneumatic work holding provision. This option plumbs air through the trunnion body, below the platter, and then through the center bore. Now you have 2 air ports that sit just below the platter surface and allow direct plug-and-play connection of the Haas pneumatic vise or any pneumatic work holding. This allows for quick, hands-free clamping or integration with a robot system like the Haas HRP series or any other. Just like all our other rotaries, we have MRZP probe templates preloaded in the software to find rotary and rotation center point, making that extremely easy with our WIPS wireless probe system. So that's the deal with the new TRT 210. The last thing I want to show you is our new pneumatic work holding option. The vise is activated via M-code, the foot pedal, or from the Current Commands Devices tab. It comes standard with diamond cut hard jaws for maximum grip, and also machinable soft jaws are available in various materials and sizes as well. Notice the bolt hole pattern fits perfectly to the 125mm spaced T-slots, so you don't have to mess around with toe clamps or subplates, which reduces unproductive setup time. Also note, it runs off the auxiliary air option, so your machine will need auxiliary air to integrate directly with the pneumatic vise. The pneumatic work holding option is a great way to decrease load and unload time and increase the overall productivity of your machine. At the same time, this reduces operator fatigue and the risk of repetitive motion injuries from clamping and unclamping a vise repeatedly, which both operators and owners will appreciate. Another benefit of the system is it ensures you have consistent clamping force regardless of the operator, shift, or time of day, so you can kiss crushed parts or thrown parts goodbye. So that's what's new for this week. Thanks for joining us for another Apps Minute. We'll see you again soon.
Hi, my name is Mitchell and I'm a manufacturing engineer here at Haas Automation. Daily and weekly maintenance is crucial to make sure that you get your Haas lathe operating at peak performance. However, the reality is that some owners of Haas lathes take better care of the vehicles in their garage than they do the machines in their shops. Taking a few minutes out of your day to take care of your machine may cost you a few bucks in the here and now. However, you will be money ahead in the long run, especially when considering the alternative of paying thousands of dollars to replace worn down components on your lathe, in addition to the loss of revenue due to machine downtime. Plus, maintaining your machine might actually be easier than you think. When I get to work each morning, I boil some water to make a cup of tea. Rather than sit there and watch the water boil, I can actually get several maintenance tasks done. The first thing you should do is apply 3 pumps of grease to the hydraulic chuck at each zerk fitting. This ensures that the chuck can properly clamp down on your part so it doesn't slip in the jaws, and it also greatly reduces the risk of throwing your part, which could damage the machine or even injure your operator. Remember, if your chuck is dry and gritty inside, this adds friction to the moving parts. This force it takes to overcome this added friction is force that's not clamping your part. Check the hydraulic pressure on the side of the machine and make sure that they are set to the correct levels so that your chuck, tailstock, and steady rest all operate correctly. Next, unlike the mill, there is no designated spindle warm-up program located in the memory of the control. However, you can still warm up the spindle by running it at 500 RPMs for 5 minutes. This should definitely be done if your machine has not run for 4 or more days, but it is still recommended for everyday use, especially if running your spindle at high RPMs. While the spindle warm-up is running, check the air lines for water by depressing the trigger on the air gun, and make sure to keep it pointed away from you. Since the air gun is fed from the bottom of the manifold, any water in the system will escape when the trigger on the air gun is activated. However, if you consistently have water in the lines, this is a sign that a bigger issue going on with the compressed air in your shop. Next, open up the diagnostics page on the control and check your air pressure and the coolant level. Check to make sure they are both at acceptable levels for operating your machine. Finally, check the coolant concentration, especially when working in a high production or hot environment where the concentration is affected by carryout or evaporation. Using a refractometer, verify that the concentration in your tank matches the manufacturer's specifications, usually between 6 and 8%. Now the morning maintenance on my machine is done, and I can enjoy a nice cup of tea. After each shift, or at the end of every day, clear off any chips present on the way covers and evacuate them from the machine using the chip conveyor. Use a brush to remove the larger chips and follow up with the air gun to remove the rest. This prevents chips from putting unnecessary strain on the way cover seals, as well as ensure that the ferrous chips, such as steel or cast iron, do not begin to rust within the machine. Additionally, check the chip strainer filter on top of the coolant tank and remove any excessive piles of chips that may be present and restricting the flow of coolant back into the tank. These are all the tasks that we recommend doing every day. However, there are some additional tasks that should be done once a week, for example every Friday. First, blow off any chip buildup on the top of the turret or inside any of the cavities. Next, inspect the air regulator pressure gauge located in the loop panel on your machine and verify that it matches the reading on the control and is within the acceptable operating range. With the diagnostics page open, check the coolant float gauge and verify that it is operating properly and the displayed reading matches the actual level of your tank. Check the surface of the coolant tank for tramp oil and remove any present using an absorbent pad. You can even use shop towels for this in a pinch. If you see tramp oil regularly, you might consider investing in an oil skimmer to keep your coolant performing at its best. If you have an auxiliary filter, check the cleanliness of the auxiliary filter bag and replace the bag if needed. Finally, if you have a bar feeder running in a high production environment, grease the bar feed push rod and bushing using a generic lithium-based grease such as Mobile Grease XHP 222. Now I know that was a lot of tasks, and some of this work is more applicable to some shops than others. You know what is best for your shop, and we encourage you to develop your own weekly maintenance checklist for your shop. But just in case it might help, we made a list of all the tasks that I just described and you can download it in the description below. And that does it for today's service video. Remember, a small investment now can save you expensive downtime in the future. For more service-related information, visit HaasCNC.com/service. And thanks for watching.
How can you unlock great savings on a new Haas mill or lathe, or rotary, or UMC, or even an EC? We've got great deals on all these machines. So many ways to save, it even confuses us sometimes. And we've talked about tax savings before, and we're going to say it again. Don't forget, the end of the year is coming soon, and locking in a great deal on a machine plus adding the bonus of tax savings is a combo that's hard to beat. Go to HaasCNC.com and you'll see our Unlock Savings banner. Savings on just about any machine, rotary, or automation combination you can think of. But let's make an easy choice. Our compact workhorse, VF2SS, coming in at $65K list. Order this before the end of our HaasTec event, September 18th, and you'll unlock special pricing and get it for just $58.5. That's 10% off. Now, if I add an HRT single-axis rotary, the savings goes up to 15% on the whole package. And step up to that same VF2SS, plus say our new TRT 210 5-axis rotary, now we're at 20% off the whole bundle. By the way, this would put a full 5-axis setup in your shop for around $90,000. These are good deals, especially considering our stock levels are dropping as the pace of manufacturing increases. That's right, manufacturing is on the upswing despite these crazy times. But you do need to act now because our lead times are going to increase. And you'll want to get in on those tax savings. Like last year, in 2020, you can expense your entire purchase, $58.5 for that VF2SS, under Section 179 for new capital equipment expenditure. If you're in the 35% federal tax bracket, for example, this will reduce your federal income tax bill by a whopping $20K. And all you'll need is 10% down. That's $58.50 to get that VF2SS on your shop floor. While Uncle Sam reduces your tax by $20K. Come tax time, your balance sheet is $14K in the black. Talk about tax relief. And if your credit's good, you can get financing with a 4-month skip. That'll put you into 2021 before any payments due. Of course, you'll need to talk to your tax professional to review specifics. But needless to say, now is an excellent time to invest in a Haas. Things are improving, which is great. But that means lead times will stretch. So act now to unlock this combination of savings with Haas's great deals and that 2020 Section 179 deduction.
Hi, my name is Mitchell, and I'm a manufacturing engineer here at Haas Automation. Daily and weekly maintenance tasks are crucial to make sure that your Haas mill is running in tip-top shape. However, the reality is that some shop owners take better care of their cars, which will only ever cost them money, than their mills, which actually make them money. Taking a few minutes out of your day to take care of your machine may cost you a few bucks in the here and now. However, you will be money ahead in the long run, especially when considering the alternative, paying thousands of dollars to replace worn down components on your mill, in addition to the loss of revenue due to machine downtime. Plus, maintaining your machine might actually be easier than you think. For example, every morning when I get to work, I make myself a cup of coffee. In the time it takes me to brew that one cup, I can actually get several maintenance tasks done. The first thing you should do is run the spindle warm-up program located on the program page. You should definitely do this if your machine has been idle for more than a couple of days, but it is still recommended for everyday use, especially if running the spindle at high RPMs. While the spindle warm-up program is running, check the air lines for water by depressing the trigger on the air gun and make sure to keep it pointed away from you. Since the air gun is fed from the bottom of the manifold, any water in the system will escape when the trigger on the air gun is activated. However, if you consistently have water in the line, this is a sign of a bigger issue going on with the compressed air system in your shop. Next, open the diagnostics page on the control and check for air pressure and coolant level. Check to make sure that they are both at an acceptable level for operating your machine. Finally, check the coolant concentration, especially when working in a high production or hot environment where the concentration is affected by carryout or evaporation. Using a refractometer, verify that the concentration in your tank matches the manufacturer specifications, usually between 6 and 8%. Now the morning maintenance on my machine is done, and I can enjoy a nice cup of coffee as well. Throughout the day, make sure to check the tool holders, pull studs, and tool tapers for damage. This can easily be done each time you need to swap or replace tools. Make sure that none of the tool tapers have rust, galling, or chips present on the taper, as this can damage the spindle in addition to causing bad finishes and part tolerances. After each shift, or at the end of every day, clear off any chips present on the way covers and evacuate them from the machine using a chip auger or conveyor. Use a brush to remove the larger chips and follow up with the air gun to remove the rest. This prevents chips from putting unnecessary strain on the way cover seals, as well as ensures that the ferrous chips, such as steel or cast iron, do not begin to rust within the machine. Check the chip filter on top of the coolant tank and remove any excessive piles of chips that may be present and restricting the flow of coolant back into the tank. And finally, if there is a tool in the spindle, make sure to remove it before leaving the machine to sit overnight. Use a rust inhibitor like WD-40 to clean and lubricate the spindle taper. Spray on a small amount of the rust inhibitor and then wipe down the taper with a clean, dry rag. These are all the tasks that we recommend doing every day. However, there are some additional tasks that should be done once a week, for example, every Friday. The first of these is to clear off chip buildup on the side-mounted tool changer arm and check for sticky plungers or worn keys. If you have an umbrella-style tool changer, make sure to clear off the chips from the top of the protective cover and check the extractor forks and keys for excessive wear and damage. Next, inspect the air regulator pressure gauge, located in the lube panel on your machine, and verify that it matches the reading on the control and is within the acceptable operating range. With the diagnostic page open, check the coolant float gauge and verify that it is operating properly and the displayed reading matches the actual level in your tank. Check the surface of the coolant tank for tramp oil and remove any present using an absorbent pad. You can even use shop towels for this in a pinch. If you consistently see tramp oil in your tank, you might consider investing in an oil skimmer to keep your coolant performing at its best. Next, remove the coolant filter from its housing and remove any chips caught in the mesh. If you have TSC on your mill, check the TSC filter on the bottom side of the TSC pump for excessive buildup that might affect the coolant flow. Replace the filter if it's necessary. And finally, if you have an auxiliary filter, check the cleanliness of the auxiliary filter bag and replace the bag if needed. Now, admittedly, that's a lot of tasks, and some of this work is more applicable to some shops than others. You know what is best for your own shop, and we encourage you to develop your own weekly maintenance checklist for your own shop. But just in case it might help, we made up a list of the tasks that I just described, and you can download it in the description below. And that's it. Remember, a small time investment now can save you expensive downtime in the future. For more service-related information, visit HaasCNC.com/service. And thanks for watching.
So we're here at the Haas sheet metal facility, and if you didn't know that Haas did sheet metal, well, this is going to be something different for you to see. So I'm here with Joe Krivda. Joe manages this place, and Joe was the manager for a section of our machine shop years ago, and as we go, we'll kind of tell that story. But for starters, how much of the sheet metal that Haas uses is produced here?
30% of the sheet metal that Haas uses is produced in-house at what we call HSM Haas Sheet Metal.
Okay, let's take a walk. So this machine's been here for a couple of years. I've seen this one before.
Yeah, this is a robotic press brake. It's been here for approximately probably 3.5 years. We do a lot of the pan parts on it, which is the bottom part of the machine. Normally it's a two-man job. Now the process is a no-man job. So load it up and walk off and let it run all night.
Okay, so same machine. It's an Armada here. What are we doing on this one?
Yeah, smaller Armada. We use that on a lot of the smaller parts. We got it running. It usually runs a lot of coolant parts, coolant tank parts, and a few other small odds and ends, and a lot of short run jobs. It's easy to set up, quick, nice machine.
And again, making a lot of parts with no people.
Yeah.
Right here.
So this is the Pneumatic 6000. It's a Trump combination machine. So it'll punch and laser. It's got a fiber laser. The laser on this thing runs about 700 feet per minute, so it's pretty fast. Typically 14 gauge.
And we're back. All right, welcome back to the second session on the third day of HaasTec Live here at Haas Automation. Again, we're here in the products area. I'm joined by Marcus Imes. We're going to take a look at this UMC 500 SS as it's attached to this pallet pool right here in a second. First of all, I just want to say thank you for all the comments that you gave us on after the first round of videos. Lots of great comments about the VMT 750. We're going to send those back to engineering and see what they can do with them. Really glad to hear about that. Please keep sending those in. We'd love to hear some examples of the actual kind of work that you think you're going to be doing on that type of machine. Really interested in that. But now we're going to look at a couple of different things here, right? We're going to first look at the pallet pool.
Yep.
Well, actually, we're not going to first look at the pallet pool. We decided against that when we were running through
Yeah, we'll kind of go back and forth between pallet pool and MRZP. There's a little bit of dead time while the probe does some probing with the MRZP. Rather than watch probe take 100 hits, we'll talk about the pallet pool.
Good time to talk about some of the specs of the machine and so forth.
Exactly.
Okay, so let's start with MRZP. What on earth is MRZP?
Yeah, so you'll recognize the acronym MRZP from our 5-axis machines and rotaries and trunnions on standard 3-axis machines as well. MRZP stands for Machine Rotary Zero Point. So that is a 2-axis intersection that tells the machine where your tilt or rotational platter is in space. And that's very important because that directly enables two of our powerful new features called DWO, or Dynamic Work Offsets, which is used for 3+2 machining, or TCPC, which is Tool Center Point Control. And that's used
for 5-axis, full 5-axis.
Yep, full 5-axis tool pass for the TCPC. We'll demonstrate that a little bit later. But if you remember in the past, on cold fire machines, you'd have to tell your cam system exactly where your part was in space, and then you'd have to come to your machine and indicate it so that it was in identically the same position. If you're off a little bit, you got a nick in the table, you got another fixture on there, well, now you got to go back to your cam system, reposition it, repost your code. Now you ran your first part, maybe you got some 5-axis offsets that aren't quite right. Well, you can't just make a simple offset, now you got to go post again. So it led to a lot of back and forth.
Potentially every time, let's say you do that job, you run 500 parts or whatever it is, you take that fixturing off, you put it away, you come back a month later to run that thing again, you can't just slap it back on the table. You got to do all that stuff again, measure it, position it, potentially repost.
Exactly.
A lot of headache, potentially.
Yeah. So we came up with MRZP. Now the machine, once you set it, it knows where in space your 0 point is, and then it knows where your work offset is, and then it can translate those at different angles and rotations, and so it's dynamically tracking, thus the name Dynamic Work Offsets. It knows where your part is in space at all times, and it doesn't care if you're in the same spot because it's figuring the difference between your program 0 point and your actual 0 point of your work offset. So you don't have to worry about it.
Yeah, so the second time you put that fixture on your table, you don't have to be in exactly the same place that you programmed it initially. You could be a half an inch off in any direction, and you're fine. The machine doesn't care. It's going to track that new position.
Yep, as long as the machine is physically able to reach the commanded positions, it doesn't care where it's at.
Right.
And we've made that process even easier now. So I want to show you some improvements we've made to the MRZP template. So we'll go to Edit, go up to VPS, and normally, this is the pre-release version, but normally it would be in your probing, but now it's going to be in Custom, and I'll load that up. And now we have two different MRZP settings. You have rough set and finish set. And we got some feedback that as we've made 5-axis machining very approachable, and now maybe it used to be a very high-level guy was the only guy in the shop that would touch a 5-axis machine. Now between cam systems getting more advanced and our ease of use features like MRZP, now we're kind of getting down to the medium level or maybe high beginner. A 5-axis machine becomes very approachable to them. But back to the rough set, finish set, we're getting some feedback that people weren't always sure, when do I need to do rough set, what is it, what are the settings for it. So we've taken some of that confusion out of there now. Now our templates will dynamically update. It'll read the settings from the machine and dynamically update and tell you if you need to do a rough set or a finish set, saving you time and confusion.
So it's basically telling you if you're close enough to avoid the rough set, right?
Yeah, and that's basically what the rough set does. The rough set is just getting a quick, it takes just 4 probe points real quick to get an approximate idea of where your center point is. Then we put the artifact, the calibration ball in there.
Otherwise known as a tooling ball.
Yeah, tooling ball. Put that in there, and then it takes 100 hits or so and gets a really accurate reading of where your machine 0 point is.
Right.
But so here, I just pulled up the template. We're only going to use one template, but you'll see the second time through, it looks completely different. So here, it's telling me I don't have valid settings in setting 255 through 257. One or all 3 of them could be invalid. In this case, I just killed one of them. But now it says my settings are not correct. We need to continue with the rough set. It says remove plug. You know, the majority of machines we sell are not the pallet pool. They're the standard platter UMC that has a little plug in the middle. Normally you just take that out and probe that bore.
Right.
In this case, we don't have that with our pallets. They just come from the factory.
Right, you're flat all the way across.
Yeah, there's 2 holes drilled in there for the artifact ball, but that gives us nothing to probe. So the first thing we need to do is, I just used VPS template to mill a little bore in there. So I just went to VPS, threw any old cutter in there. We have a circle pocket program, and I just milled a 1.5 inch bore.
And so since this is just for the rough set, you weren't even, you pretty much just want it to be relatively round.
Yeah.
And some diameter, right?
Yeah, I didn't even measure it. It's not that important. You just have to be approximate at this point. All the final settings come from the finished set. By default, this will be 2.0 inches for the diameter because that's the diameter of the standard platter bore. But I didn't want to do 2 inches because we have those 2 holes in the platter and it would interrupt those. So I just made my bore 1.5, I'll call that. The height also defaults to 2 inches. The standard, the standard platter is -2 inches in Z between the center of rotation and the platter surface. This machine is 0.515 inches above center of rotation. Kind of a random number. You might wonder how I found that out. We got all this information on our MLDs, the machine layout drawings, which are available on the UMC 500 product page. And
the MLDs are available on the PDP.
Yes.
Yeah, we've had a lot of questions about where do I find specs for my machines, particularly new machines, and all of that information is available on a separate tab on the product description page for every machine that we make on our website, on HaasCNC.com.
And same thing with the 3D models too. We're revamping our entire 3D model lineup, and they're very, very accurate to real life. One of our Texas,
you have an actual example of that, right?
Yeah, one of our Texas HFOs, I made the mistake of asking on a public Zoom call, and I guess I didn't know the answer at the time, but I was like, hey, are you got any problems? I'm looking for some feedback. And he actually said he had a UMC 1000 part, and he had about a 1/2 inch clearance to the tool probe on the side. It was a really big part, barely fit in the machine, and he used our machine model, and he said, hey, we got about 500 thousandths clearance, and they sold the machine, did the application, and it came out dead nuts on. So you'll see the new models are very high fidelity and actually come directly from engineering, and then we take out some of the extra stuff. So that's a really good resource.
So you've got access to both of those things on the product description page.
Exactly.
Cool.
Anyway, so yeah, I got my 0.515 from the machine layout drawing. And my angle, I'm just going to leave that at 0. Often you don't have to change that. If your probe comes over and falls into one of your T-slots, you can change that angle. And my distance, 1/4 inch, that sounds good to me too. So now I'm just going to call up my probe. All of our 5-axis machines come with the WIPS, the wireless intuitive probing system, which none of this would be possible without. I'll call my tool and probe into the spindle here.
So do you want Sal to come and look at this now, or?
Yeah, Sal, you can come over here.
Peek in the window here now.
And basically, I'm just going to move. I'm just going to position the probe right over the middle of the bore. Don't need to be terribly accurate, but want to be approximately in the middle. And I think, let's see, 10.9 is the number I'm looking for. I know that works well. All right. Got my probe right over the top there. I'm gonna go back to my VPS template, and I'm just gonna hit cycle start from there, and that'll load whatever is in the VPS template to MDI and start running that. So see here, it takes a couple hits in each quadrant.
Actually, yeah, maybe we want to push back in there, Sal, and see that. Just do it slow. So this is, as you were saying, this is the quick version, the rough set.
Yeah, it only.
So here it's really what, just 4 points?
Yeah, I think it touches each quadrant twice.
And it's going to touch off the top, right?
And then Z once.
Right.
So now the machine knows approximately where that center of rotation is.
Right, right.
And that's about the end of that. So now we can get this out of the way. Now on a normal machine, I would just take my tooling ball and install it on the table. But because we have the pallet pool here, I'm actually going to do a pallet change.
Sounds good.
We'll go over to our current commands tab, and if you tab to devices and then pallet schedule table, here's where we control everything for the pallet pool.
All right, see, okay, yeah, maybe we'll jump up on here now.
You can see in the pallet pool, and Sal gets over there in a second, this is the 16 plus 1 station pallet pool, so you have 17 pallets total. This is really good, like Corey was showing you the APL earlier. The pallet pool, the APL is limited to about 6" by 6" part size, so a little bit smaller work. The pallet pool, you go up to 8 by 8 by 16. So if you've sized out of the APL, but still want an automated loading solution,
right. This is your next option.
The pallet pool is your next option.
Right. And you were telling me that at that point you are pretty much constrained to that size, because the pallets aren't very densely packed in there to get that many in there.
Yeah, when they cut to the pallet pool, you'll see there's basically no room between the pallets, so no, you cannot make an 8.5" part, or 8.0, that's it.
Right, right.
We'll have a robot option too in the future for even more flexible loading. If your part size is out of both of these, the robot will be a good option, and that's coming in the near future as well.
Right, right.
So you can see here we have our pallet schedule table, and I know pallet number 1 is my artifact ball. So I'm just going to push Alter to load that pallet.
So is this an example of where you were inserting a kind of a non-scheduled pallet into the stream?
Yeah. Yeah, the scheduler allows me to, just like our other machines, Milton and John kind of talked about it the other day, but you associate a program to a pallet, so you can never run the wrong program with your pallet, and then you give it an order, and I want to run pallet 2 first, and then 16, and you can dynamically update that list at any time.
Right.
And it just keeps bumping down.
So in order to load that individual pallet, if it wasn't already in the sequence, you need to pull it into the sequence at the top, basically?
You can either do that if you want to wait until your current operation is done, or if you just want to throw it in and begin, I pressed Alter to load pallet and program.
Okay, right. So that just grab that singular one if you're doing work on just that. Maybe you aren't running the pallet pool at that point. I just want to access that pallet now.
Precisely.
Okay, cool.
And one nice thing, we made this really easy. If you have existing UMC 500 programs, the only programming change to turn into a pallet pool program is you replace the M30 ending code with M299. And M299 acts like M30 if it's in single cycle mode, it just finishes and stops. Or if you have it more pallet scheduled after that, it'll continue running the next pallet.
Right, right. Similar to how we run the APLs, kind of the same idea.
Yeah, we kept the programming structure very similar.
Right, right.
So really the programming difference between an APL job and a pallet pool job is nothing other than the setup.
So here you've got the pallet scheduling business to worry about, but yeah, there you're I guess you're scheduling parts, if you will.
Yeah.
And here you're scheduling pallets, but it ends up being similar.
Yeah, so this one you have the flexibility of running 17 different programs, or more if you had multiple programs per pallet. That, with the APL, you're more or less bound to one program per APL setup.
Until you switch over. And that's a huge difference, of course. It's not just the size of the part. But
Yeah.
here, yeah, you potentially have 16 different jobs here, or maybe, you know, half and half. Maybe you're running high volumes on a couple of parts, or, you know, any mixer you can think of, really.
Yeah, that's a good way to put it, is that machine might be geared towards a little more high volume single part production. This is more low volume, high mix.
Right.
Or it could be high volume too, just with a larger work envelope.
Right, right.
All right, so now my tooling ball has made it in there. And I'm gonna go back to my VPS template.
Yeah, so for now, I think we want Sal to come back and take a look at this part of it, I think, from the front, right?
Yep.
Sal, you wanna, when the DJ over there tells him we can go.
Oh, one thing I forgot. I went back to my VPS template and it still looked the same. When the new software comes out, we have an awesome new G code called G167, and this is writable parameters. So right now, to get my settings from the probe into my MRZP settings, I have to go look at my macro numbers and then go back to my settings and manually enter those numbers. That enters a lot of possibility for fat finger mistakes or, you know, transposing a number. It's easy to do. I did it when I was setting up. And
yeah, not ideal. So we're fixing that.
Yeah. So now in the future, G167 in the next software release will allow us to read those values and automatically write them to your MRZP settings. So you don't have to guess about which setting, what's a master, what's a slave. You don't have to worry about any of that. It's going to take care of all of it for you. And it'll be more than just MRZP settings. It'll allow you to set work coordinates and some other common user settings that people have been requesting for quite a while. So I think that'll be very much appreciated by our users.
Yeah, for sure. But you're going to walk through those particular screens anyway, so give people a chance to kind of see what you're talking about as well.
Yeah, exactly. So for now, I knew my number ahead of time. I just copied it over from my macro values, and now I'll go back to my MRZP template. The exact same template, but now you'll notice the screen is totally different. It read those MRZP values, it decided it had an approximately good value, and now we can continue with the finish setting.
Right, so it knows that rough is good enough now, basically, right?
Yeah,
So
exactly.
you might come up to your machine and wonder which step you needed to do, and it may already be in that stage, knowing, oh, I know rough's good enough, I'm ready for fine.
Yep.
Or maybe like it was here where...
That's exactly the advantage, is you don't have to wonder anymore, you don't have to go find the high-level guy who knows everything. We're doing a little bit of the basic thinking for you here.
Right.
So now it's asking what kind of tool ball I have, mag base or the solid ball. We're shipping everything with the solid now, so I'm just going to enter S. It'll bring up a few more options, and it's just telling me to jog the probe. Another nice feature you'll see on a lot of our MRZP templates, and like Corey was showing you with the APL setup, got a lot of GIFs in there, so if you're not sure about exactly what we're asking for, just spend 10 seconds and watch the GIF. Movie's worth 1,000 words.
That's right.
And now it's asking for the diameter of it. By default, this defaults to 1 inch, but this is actually 25 millimeters, which you machinists will know is 0.984. So don't assume your ball is 1 inch or 25 millimeter. Take a mic the first time, check it. For finish setting, it does matter.
Right, at this point, you do need to worry about that a little bit. You've got that ground ball in there, you may as well know exactly what diameter it is.
Yeah, at this point, for the finish setting, we want to be very accurate because this will determine our overall volumetric accuracy of 5-axis moves anytime we're not at B0, C0.
Right.
All right, so now I'll just come over and hand jog that down. And again, I'm just putting it over about the middle top of the ball, about like that. Go back to my VPS template, and I'll hit cycle start, and that'll start the probe here. And the first question it actually comes up and asks, would I like to probe at B90? So obviously, to get the tilt center line, we can't probe just at B0. We need to be some degree off of that.
You have to have an angular motion in there.
If I answer no, it'll go to 0, negative 35, positive 35. And that's good, that gets pretty close. But a lot of times we're gonna be working at B90, and for the most accurate representation of that point in space, we want to probe at 90 degrees in any case that you can.
There are reasons why you might not be able to do it at 90 degrees though. That's why you have that option though, right?
Yes, this is why we ask you. The Haas tooling ball that comes standard is long enough that it clears from the spindle center line to the side of the spindle head. If for any reason you lost this, you can buy another ball, maybe it's a little shorter. Make sure you got enough clearance there so the side of your spindle doesn't crash the trunnion when it's at 90 degrees. But if you're using all the included equipment, you can say yes, and we would recommend you say yes anytime you can. So I hit yes again, it's going to ask me to hit cycle start one more time just to make sure. And now it'll start probing the heck out of this. And this cycle runs for about 7 minutes, so we'll let you watch a little bit of it, but we're going to start talking about some other aspects of the machine as well.
We'll watch it for like 10 seconds.
Yeah. You guys have probably seen probes hit 1,000 times, and if you haven't, here's a couple more for you. All right, so while that's going on, let's get a little bit better look at the pallet pool here.
Let's move over here. I'll move over out of your way a little bit.
This is very similar to our other palletized machines. We have the ready button here, so when you're in automatic mode and a pallet finishes, the pallet pool will automatically drop it off here at the load station for you to reload and do whatever you need to with. We have a couple handy features I'll show you. We put the slot in the side here, so you can spray off some chips and coolant without hosing yourself down. I think we've all done that a time or two. The pallet indexes, just like our other ones, so if you had a multi-sided, you could probably fit a real small tombstone on here potentially. If you're making maybe like little medical parts or electronic parts. You could stack them, up to 16 inches high and actually run a lot of parts on one pallet. That's handy. We have the home switch here and position switch in the receiver, and so it has to be at home before it'll unload the pallet. So if it won't do it for you, double check that you're at home.
Right, so just like the ECs and the VC400, you only got the one spot where you can really, where it knows that it's ready to go and you're safe to load the pallet.
Yeah, exactly. And same thing with the operator door too. We got a proc switch up here, so it'll tell you the door's open. I can't go in there.
Right, so the pallet changer's not going to come around and try to ram into the door. That'd be bad.
Crash proof it a little bit. And you can see the pallets here. It comes right off, but maybe if you're cranking on a taller fixture or something, obviously you don't want it falling on you. This lever here, now the pallet's locked to the base. And so really anytime you're reloading, it's probably best practice to lock that lever in place so your pallet can't tip over, fall off, hurt you. And if you forget to unlock it, you can actually leave it locked. We designed it so that when the forks come in, it just pushes that lever open, unlocks itself, so you never have to worry about it trying to pick up a locked pallet.
Right.
So one more way, crash proof things a little bit for you.
So we kind of talked about the work envelope that you've got here. So it's 8 by 8 by
16 tall.
Okay.
And the 16, if you were to go all the way up to 16, you don't have a lot of room left for your tool, because you have about a little less than 20 inches of total Z clearance. So if you are going to do a real tall part, again, look at the machine layout drawing, do a work holding plus tool stack up, and decide if you can make the parts in that work envelope. Cool.
Well, we talked about what you do to prep your program. All you need is an M299 to turn into a program that's accessible for use on the pallet pool, right?
Yep.
I think that's kind of about it, right?
Yeah, so this is
anything else you want to say?
Yeah, I think we're getting close to the end of the probing cycle here. And just to show you why all this matters, I took a little program. I just hand wrote a program using tool center point control. And we'll show you the difference between maybe like in the past how you would chamfer something, and now how you could do a 5-axis chamfer. And we'll do some pretty fancy 5-axis moves, and I programmed this all by hand. What would have taken thousands of lines of code in the past now is just one line of code and a bunch of fancy math in the background that some geniuses up in software figured out. So thanks, guys. I don't have to do that math.
Yeah, right.
I appreciate that.
And so that's something you have to have your MRZP correctly set for, though, right?
Yeah, exactly.
Otherwise, you're going to have some interesting incidents happening.
Yeah, I don't even actually know if it would work. I've never tried it.
Yeah, maybe
but,
it wouldn't. Yeah.
It probably wouldn't. I'll assume not.
Cool. So are we coming to the end here on the probing, or?
Yeah, we're getting close. So, yeah, just to emphasize again, a lot of people were asking about the vertical mill turn, and Haas is really expanding our. It was funny. I was at IMTS last year, and everyone told me, Haas is never going to make a mill turn. Well, I've learned never to say never here at Haas, because when we see a good opportunity in the market, or same thing with like a lot of our automation, you'll notice a lot of new pallet pools are coming out for a lot of new machines.
Yeah, we've really been making huge steps in those directions, in multiple directions. Robots, automatic pallet loaders, pallet pools.
I heard rumblings of an EC 1600 pallet pool.
Wow.
That's still out there a little bit, but...
that's a whole different scale of parts right there.
Yeah, so for the big stuff, those big customers are not being ignored. We're just kind of working our way down the machine line. And I think everyone's trying to make more stuff with less people and keep that spindle turning more, because that's how you're making money. And
that's right. I mean, this is another example of this machine is one that you can set and forget to some extent. I mean, you've got 16 pallets. You're running unattended for a long time.
Yeah, you load this up at the end of the night. You got to figure most 5-axis parts. It's not hard to get an hour or a half-hour cycle time on that.
Right. So this thing might be still running the next morning when you come back in.
And that's exactly what we're thinking with it. Is this is free money at the end of the day. You load up a pallet pool or an APL, and you combine that with our WIPS wireless probing system. If you're doing a lot of unattended work, it may not be a bad idea to probe the part every time, just in case you get a misload, or we haven't observed any problems, but when you're doing unattended, it's always nice to do some broken tool detection, which the VPS templates also allow you to program really easily.
Yeah, we've talked about that. I think we've talked about that a little bit this week. I think actually on Friday, Mark's going to even talk about that a little bit, about how do you kind of proof your program so that you're going to run well unattended, because a lot of things can go wrong that an operator might be able to take care of if they're standing there by the machine. But if you've got no operator there, you need to make sure things are a little more locked down. And like you said, things like a probing check in between cycles.
Absolutely.
Did I load my part correctly? Did I do all my features correctly?
I come from many years of Swiss background, and when you came in the morning, if things were bad, it was a pile of bad.
Right,
it was never just one thing bad. It was almost everything. So the number of checks you can put in there to prevent cascading crashes from happening takes a little extra time in cycle, but when you consider you're getting 8, 10, 12 hours of free labor.
Yeah, you're doing that work without anyone standing there anyway, so it's probably worth those safety steps.
Yeah. All right, so now we're done here. If you saw the observant people would have seen the red light flash for a second. That's because it read the G167, but that's not in software yet. That's our parameter write code. So that was the new template trying to dump all those numbers we just figured out into the appropriate parameters. But now you can see we do have good numbers in there, and I'll do one more pallet swap, and I want to show you what this all is used for with a little tool center point control dance. So I'm going to take pallet 4. Let's see here. And I'm going to load that up with insert. Oh, operator station is not locked. It is locked. Never got that message before. It says operator station is not locked. Doing some thinking for you up here. All right, minor technical difficulties. I've never gotten that message before. Operator station is not locked.
I don't know.
Oh, I know what it is.
Yeah, this one's out of position.
It's the home switch.
There we go.
Remember that home switch?
I was sweating there for a minute. Hey, it worked like it was supposed to work, actually.
How? I can't crash the machine.
It didn't want you to load that way.
Yes. All right, there we go.
Cool.
Do a little bit of thinking for us. Thank you, machine.
It's always that way, right? You're like, why isn't this thing working? Well, it's actually telling me that I should not do something that's unsafe.
And actually, that's something that I used to do a lot of in the field training. And often when you're having problems, people, you kind of look at the last thing that happened, but oftentimes your problem started several steps ago. So that was one thing, particularly in Swiss, when everything's got to be perfect, when I was trying to hold 3/10 all day. You really got to go back through all the steps from the beginning, and lots of times you'll find little things, maybe you didn't set a work
wasn't
offset
quite right or something, or
early on, and that will have a cascading effect. So it's always good to double check from the beginning, because oftentimes it is something very simple like that.
Right. Well, it's a lot like the comment we got at some point, I think, in the last day or two, where the guy was like, I can't hear the audio. And then a couple minutes later, he said, well, I forgot to plug my headphones in. So, yeah, you got to do the basics first. Okay, so you're loading.
All right, now I'm going to take the other pallet out of the machine.
Right.
Swing that around.
So we put away the pallet that was in there.
Yeah, it always has to put away the load station pallet, and then it'll get the one from the machine, and then we'll grab the other one.
Right, so you put away the one that was in the load station, you're going to put that pallet into the load station,
yep,
and then get the one we want to load.
Exactly.
Right. Cool.
See that slide in there on Sal's camera? I know this all clears. I suppose I probably should have sent the probe home, but I know that we're safe either way. Don't want to mess up your nice fancy probe.
So in this case, we both are we supplying that particular artifact, as you call it, or tooling ball?
Yeah, that
in this configuration. If you're getting the pallet pool.
Yeah, the tooling ball comes with your whip system, and we pre-drill the holes in the pallet for it.
Okay.
So
that's what you were saying.
Yeah.
That's the ones you didn't want. You didn't want a machine when you were putting your extra bore in there.
Yep, that comes from the factory. And now. We will load pallet number 4.
All right, so now we're going to get our rotary table.
Yep. And now this will be this will show you why all this matters. I'm sure a lot of you are familiar with MRZP and tool center point, but to those who aren't, we'll show you how much easier this makes it, because what I'm doing in this program with a few lines of code literally would have taken thousands of lines of code and a very expensive CAM program in the past.
Right.
And now it's become so simple you can do it by hand, and it took me about 5 minutes.
That's crazy.
I will mention to go from a standard tool height offset to tool center point, machinists will recognize the G43 code as tool height. G234 is tool center point control. So whereas G43 tool height is only looking at the length of your tool sticking out of the spindle, G234 is looking at where your tool tip is relative to the work coordinate systems at all times. So in 5-axis, if I did like a sweeping move with only G43 tool height, it would actually cut a scallop through my part. But with tool center point control, the machine's going to actively track where that is and maintain that point in space relative to the workpiece at all times.
Right.
So I'll call up my program here. And Sal, if you want to come in here. So this would be just kind of a standard 2-axis deburr path. This kind of traces around the outside. We could orient that to a couple different positions. But now here's a similar thing with tool center point control. I really like that last move because it kind of helixes in, but that's actually drawing a straight line as it goes around. And all my rotary moves there, I'm counting it right now, I got 6 lines of code to do this.
Pretty cool.
So as you can see, that makes it a lot simpler and just a lot more user-friendly. And the code is a lot easier to decode too. If you got a bunch of random C and B values and you're having a problem like gouging is a real common 5-axis problem. And trying to figure out, exactly which line of code is doing it when you have 100,000 lines can get pretty tricky. I've been in some shops and we've struggled with it in the past. And the tool center point control.
Machines are just coming with it. It's just kind of it is an option, but it's just, yeah, it makes it so much easier.
Yeah, it makes it easier because now you're looking at relatively standard G code, and it's just a lot easier to debug when you do have a problem.
Yeah, you think there's no reason that you would invest in this machine and not take advantage of that technology.
Absolutely.
Yeah, it's just so straightforward. Well, I think that's kind of it, right?
Yeah, exactly.
Thanks so much for walking us through this machine, pallet pool, and in-depth introduction or refresher on MRZP. I'm going to call Brian back out here, and we're gonna take this thing out again.
Thank you, guys.
Thanks, Marcus. All right. So wrapping up day number 3.
Man, no wonder Marcus was sweating. It's hot. We're in a real dark corner, so we got a bunch of lights here. So sorry about that, Marcus.
That and our pallet not loading there for a moment because the machine is trying not to crash.
It a little bit. So thanks, guys. We appreciate you joining us today. Now tomorrow is an early day for us.
That's right. So we're back again tomorrow. It's Thursday, so we're going to be here at. We're gonna be turning this thing on at 7 a.m. We're gonna be here much before that. Much to our chagrin. So we're gonna be doing 7 a.m. tomorrow, and then again at 10 a.m.
Yep. And Frank, if you pull up the schedule, please. All right. So we're gonna start just off to my right. We got 2 big boy machines tomorrow. We got the UMC 1500 Duo.
That's right. I'm gonna be doing that one with Milton, and then you've got the UMC 1600H.
Yep. UMC 1600H. That's gonna be myself and John Nelson. In the afternoon, we're going to change locations.
Yeah, we're going to run from here over the demo room somehow.
Yeah, and that's going to be at, what time is that, 10 a.m.?
That's 10 a.m., yeah.
Yep, it's probably on the screen right now. So 10 a.m. Pacific, 1 p.m. Eastern, we're going to be in the demo room. We're going to talk about Haas tooling. Now, a couple months ago, we did Haas tooling, and we got into some very specifics of tools and part numbers. We're going to take a higher level view. We're going to show you everything that we've added to the website, which is a ton. We're going to talk about the Haas Tooling Buyers Club, and then we're going to show you a bunch of stuff that's coming soon.
Right.
We've got work holding coming, a bunch of lathe tooling, a whole bunch of stuff, so you'll want to be here for that for sure. Let's close with the promo.
And at the very end of that, we're going to take a real quick look at another thing that's up and coming, what we call the HTS 400. It's Haas's first shot at a tool presetter, so you want to stick around for that. We're going to do a quick one on it, but it's definitely worth seeing.
Yep, you'll want to check that out.
So the promo, of course, can't stop without doing a promo.
That's right.
Shout out.
So we've got the Unlock the Savings promo, which we've been running for a couple of weeks, but this week only, we've got an additional kicker for you.
That's right. You got 2 more days, Thursday and Friday, to get an extra 5% off of the already really great prices online. There's a wide variety of machines and rotaries and pretty much everything we sell. Not everything, but almost everything.
Just about.
So if you're in the market,
go ahead.
As you love to say, you don't even have to do it. You don't even have to talk to anyone. Just go on HaasCNC.com, go on the build and price tool, and build and price that machine. See how much you can save.
That's right. So thanks again, everybody, for joining us. Reminder, tomorrow morning, 7 a.m. Pacific, 10 a.m. Eastern.
We'll be here.
Yep, we'll be here. We'll see you guys tomorrow. Thanks for joining us.